Energy. But what is energy really? Is it the jolt of strength we get before we pass the finish line at the end of the race? Is it the inspiration we get when we see something new? Is it the tireless pursuit of trying to move forward? Energy is the power which drives our lives forward everywhere. We have learned to transform it from different sources and to use it at our will. We create energy and we give it direction.
All right, now hold it down.
We are the people who develop the future technologies today. What will they be like? It only depends on us. In the last decades, the vision of energy has significantly changed in many countries. And now, in this period of evident transformation, we can't miss the opportunity to find the answers to the most important questions. What drives the energy industry? What are the directions and tendencies of the energy industry? What lies at the heart of the frontline research? Which applied technology draws the most interest for the Russian industry and for the world industry in general? The leading world scientists, together with the bright minds of the new age from universities and international companies, every day are seeking the answers to these questions. The result of their work will be presented at this international scientific practical conference, Energy Agenda of the Future. We will take a look at energy from a different perspective, in an alternative way. Welcome to the International Conference, Energy Agenda of the Future.
Dear participants, we are very happy to see you today.
Let us welcome you at the International Scientific and Practical Conference for Young Engineers for Fuel and Energy Sector, Energy Agenda for the Future.
Today the session moderators are Irina Ivanova,
my colleague Nikita Panov, and our third colleague, moderator of the Zoom chat, Alexander Parin.
Dear colleagues, let us remind you that 2021 has been declared the Year of Science and Technology in Russia. The objective of the year is to attract talented youth to the field of science and technology, to increase the involvement of the professional community in the implementation of the strategy for the scientific and technological development of the Russian Federation, as well as to form a clear idea among the population about the initiatives being implemented today in the field of science and technology.
Today's event is held with the grand support of the Federal Agency for Youth Affairs, Rosmolodezh. The conference aims to bring together industry professionals, researchers and proactive representatives of the youth energy community to discuss the most important, the most pressing issues of the world energy.
What are the research direction of the of the world's leading scientists? What can the young staff of the academic community in the industrial sector say to each other?
What do young scientists think about the core of the frontier researchers' agenda? What energy technologies are the most interesting in adopting?
Now we invite you to look at the screen.
Yeah.
More than 270 participants from different countries and continents are registered at our conference. The conference brings together the leading researchers from around the world, including representatives from Denmark, Canada, USA, Italy, Poland, China, Finland, Turkey, and many others.
The topics of the report lays in a variety of fields, but mainly focuses on aspects of power electronic and energy efficient technologies. The conference arouses significant interest not only among educational organizations, but also among the participants from energy companies.
We believe that the conference will become a platform for the exchange of the most progressive ideas. And today the conference is hospitably hosted by St. Petersburg Electrotechnical University, Leti. And we are very happy to welcome the Vice Rector for Research of the University, Viktor Tubik.
Dear delegates, organizers of the conference, guests, on behalf of St. Petersburg State Electrotechnical University, LETI, by the way, this is the first electrotechnical university in Europe, I'm happy to welcome you at the first international conference which looks into the energy-efficient energetic sector of the future. And today it is the most pressing theme on the world agenda. And it just happened that our university is turning 135 years since it was founded, and throughout its history we were always engaged in energy issues. I am happy to see a very representative audience at today's conference. You saw the world maps with the delegates, countries of origin shown on the map. I am very happy that leading Russian university representatives will be delivering at this conference along with leading Western universities, and I'm happy that dear Professor Blaabjerg is one of the organizers of this conference, and we've been cooperating with him personally for many years, and I hope this cooperation will continue. Energy efficient energy sector of the future covers so many research, electrical energy, and of course social themes. And I'm happy that our conference focuses on young and talented engineers, researchers, managers, and of course students. So these are parties engaged in discussing tomorrow's agenda, but tomorrow they will be implementing it. I wish all of us success, fruitful discussions, and of course, Merry Christmas and a Happy New Year. And stay healthy. The best of luck to you.
Viktor Anatolyevich, thank you so much for your greetings.
Now we are glad to invite to greet the participants and to launch our conference Natalia Trifonova, Executive Director of the Organizing Committee of the conference.
Dear delegates, dear audience, guests, and all who are present here, I'm very happy to see you today at the conference. The idea of the conference was conceived about a year ago, and we thought of bringing together young professionals from the industry and young people from the academia. It allows to unite different generations as well, because the energy agenda and the future of the energy sector must be discussed by professionals of different generations and from different industries who are interested in developing the Russian and global energy sector. So we decided to have this conference during pre-Christmas and pre-New Year time, because this is when miracles happen. And the first miracle happened because we received the support of our partners who saw the potential of the conferences, and they saw the impact that the conference can make. And the dialogue which is possible at this conference. The dialogue is of a paramount importance, because this is exactly what young people do. They are able to bring across most brave ideas. They are innovators and they want to fight with stereotypes. And also, the industry representatives who are most experienced and have the best practices, they have the intuition in selecting from the novice approaches things that will be the main area and main road for the development. We are at the brink of the energy transfer. We are interested that more companies, organizations, and a wider audience are engaged into the dialogue. I am positive that platform is here, our conference for such debates and discussions. Our objectives are to touch the most pressing challenges, to discuss the technological development fields, the development of markets, digitalization, and staffing challenges faced by the industry. We are not afraid of challenges. This is the first conference in this respect. We are not afraid being pioneers to make mistakes. Presentations are varied, but the young participants at the conference must learn to hear each other and to learn from each other. And I'm ready to pronounce the words everyone is waiting to hear. The conference Energy Agenda for the Future is open. Thank you, dear guests and delegates and all who are present here. I wish you the best of luck. Мы даем слово директору фонда «Надежная смена» для приветственного выступления Артему Королеву. Good morning, colleagues. Can you hear me all right? Esteemed colleagues, attendees, and friends, allow me on behalf of the Reliable Change Foundation and on behalf of the steering committee for the Case-In Championship to welcome the attendees of the conference. I would like to primarily thank the conference organizers and most of all St. Petersburg State Electrotechnical University, LETI, for supporting the young people from the industry and for engaging the young people into the implementation of the strategy for the technological development of the Russian Federation and for involving students into this field. I would like to personally thank Natalia Trifonova, who is a driver for her team, making these events a reality in Russia. I would like to thank the Federal Agency for Youth Affairs, Rosmolodezh, for supporting this project, and I rely on their support in the future. So the young professionals in the fuel and energy section was set up 2 years ago, and they participate in arranging the event, and they are the speakers at the event as well. So we have the world energy landscape changing. Therefore, it's important to have the platform where professionals meet the young people who are actually the implementers of the future technologies, the technologies we discussed today as breakthrough. So what are the technology most promising for the global and Russian industry? What are the areas of research in today's research community? So these are the questions raised by the agenda, and therefore it raised the interest of experts from around the world. It touches such issues as frontier research, energy, efficient solutions, implementation of sustainable development principles, and preparing, training future professionals, digital transformation of the companies. That's another topic. So there is this online remote conference. It engages experts from Denmark, Poland, Finland, the United States, Turkey, and other countries. And though the conference happens at globally difficult times, but current constraints allows to have this new format of cooperation, allowing young people to communicate remotely with leading experts. So there are young researchers, they are interested in studying new technologies, and they are attracted to this conference. The conference allows to demonstrate companies, their interests, as well as educational establishments may advertise themselves. We must assure that there is the succession between generations and the quality is a key, even with progress and development. So new ideas and professional skills, this is the foundation for the energy sector development. I wish you find like-minded colleagues, and reinforce friendly and professional connections. There will be bright ideas, I'm sure of that, but also practical recommendations, I hope. So, and these ideas will be highly valued by the industry and world academia. On behalf of the Reliable Change Foundation and on behalf of this community of young professionals in the fuel and energy sector, I congratulate you on the upcoming Power Engineers Day. So join competitions, which are organized by my foundation and by Championship Case In. I would like to thank personally Natalia Trifonova and her team and the entire LIT University for having this conference.
Thank you so much for your greetings.
Now I ask you to greet Stanislav Eroshenko, Vice President of the International Section for Youth Activities at SIGRE. Please, you are welcome.
Dear colleagues, thank you very much for the opportunity to speak. So do you hear me? It's okay? Perfect. So first of all, my warmest greetings to all of you and thank you very much for giving the floor. Well, here today, I'm on behalf of the SIGRE. You know, SIGRE is one of the biggest international non-commercial communities standing for research and investigation of bulk power systems in the world. And well, SIGRE has an international executive committee of young professionals. So we call it Next Generation Network. So here I represent NGN on behalf of the vice chairman of this international community. Well, before I start talking about main goals and tasks of SIGRE and how these tasks are related to the goals and topics of today's conference, let me briefly introduce you the geography of SIGRE community. Well, here you see the geography of NGN groups existing in the world. Well, to be honest, Russian NGN group is one of the biggest. So we have about, if I'm not mistaken, 400 or 500 of members. But anyway, there are 26 established NGN groups, and the number of NGN groups in the world is growing permanently. And even now we have the requests from other countries for establishment of these NGN groups. So before talking about the benefits, yes, which SIGRE membership give to the young members, let me give you a brief introduction of the Russian NGN community, because, well, I am half the representative of the international community and the Russian National Committee as well. Well, Russian National Committee, Young Section, NGN Group, is established with the following structure. So we have a chair and vice chair, the secretariat responsible for implementing all of the activities, including conferences, quizzes, championships, whatever, for young professionals and students of the higher educational institutions. Secretariat and organizing committee interacts with regional coordinators. So here you see the map of Russian Federation, and the map illustrates the regions which are involved in a Russian National Committee NGN group activities. And actually, it is not just one or two activity. Actually, it's a very interesting annual plan containing even case in a very important international championship on engineering cases, various conferences supported by SIGRE, IEEE, different competitions for the students, whatever. So, and by implementing this structure, Russian National Committee, NGN Group, interacts with the students, interacts with the universities, and what is more important, establishes interaction between higher educational institutions and the industrial companies. Well, speaking about a little bit in more detail about the benefits which SIGRE membership gives to their members, to the members of the NGN groups, and actually more specific about the roadmap, yes, and the goals and tasks of the NGN community, I would focus on the following points. So first of all, so we pursue promotion of science in the sphere of power and electrical engineering, because the conferences covering power and electrical engineering tracks, even educational tracks as well, are very important. So we promote the education in the sphere of higher education of electrical and power engineering as well, for higher educational institutions and even for high schools as well. So we try to establish, and we do our best to make students' collaboration effective throughout the world. So by entering NGN community, you will have the opportunity to, I would say, to touch the best practices in the sphere of power and electrical engineering, and to build your team, to find your colleagues, and to build collaboration links with the students all over the world. So, and what is really important, and we believe that it is one of our global strategic goals, is to build the collaboration and connect industry with academic environment, because industry has their own young professionals and not so young professionals as well, actually. And the academic environment requires establishment of this collaboration with industrial companies to focus on the top topics which are on issue in up-to-date world, including global energy transition, digital transformation of the industry, whatever. And well, typically it is beyond the borders of consideration, but I like to tell that SIGRE provides some sort of lifelong membership, not exactly membership, but what I want to say that students who enter SIGRE activities, who enter SIGRE community, typically after graduation, yes, so they are employed by different industrial companies, and in the majority of the cases, they come back in a little bit another role, because they come back as expert and support students, support academic environment as well. So it is a sort of the family, rather big family, which has their, I would say, branches all over the world. So we have even some meetings, online meetings every month. We have some on-site, so we had some on-site meetings when there was no pandemic. Yeah, but anyway, so we meet each other. So we have these ice-breaking activities. So we have this annual roadmap having lots of very interesting and significant activities for young professionals and students. So we invite you to enter SIGRE, become our members, to enter power engineering community, and to develop with us. Thank you very much for your attention, and hope to see you at the conference sections. Thank you.
Mr. Eroshenko, thank you very much for your very interesting presentation.
Now let me introduce our very distinguished guests to you. First, the chairman of our conference, professor of Aalborg University, laureate of the Global Energy Prize 2019, IEEE Edison Medal 2020, and many, many others. Author of more than 600 journal papers in the fields of power electronics and its application.
Hello, Mr. Blaabjerg. Very nice to meet you.
Yeah, hello everybody, can you hear me?
Yes, so participant can hear you, and you can...
Good morning, good day, good evening to everybody. It's a very great honor for me to be by you today, and also have the, let's say, the responsibility to be the chairman of this conference. This would never have been possible without Natalia, who has been an important player to gather a global representation of this very important event. I was invited to come to St. Petersburg, but it was not so easy, even though I would like to come to St. Petersburg. So this has to be very soon when things are becoming more stabilized. However, despite we have a pandemic, we also have a very big challenge in general to look into the future and create what I would call a sustainable society for the human being on the earth. Therefore, this conference with the title Energy Agenda for the Future is of great importance for the energy society, where people are meeting and discuss what are the future solutions in order to create a sustainable society of the world. And the people to fuel and energize this transition, there is no doubt these are all the participants here, the young engineers who are going to work on those subjects here and try to come up with smart solutions for the future. So a conference like this, which is highly appreciated from my side, is of course a place to get new ideas, make network in between on Zoom and YouTube and so on is not so easy. So maybe in the next year to come, this will be a possibility. But then also I would highlight the importance of thinking across disciplines. So we are not only thinking about, let's say, small, narrow electrical engineering, but we also have to broaden our knowledge in order to come with smart solutions. So in my speech here, I will just highlight something from my chair, which I think are very important to have attention to when we work in those fields here. One is by no doubt that the world has decided to reduce the carbon emission, and by that reducing the load of the earth in terms of temperature increase. And there are of course many ways to implement that, which we also see when looking at different countries. But the overall arching goal is to really to reduce the emission. And the timeline we are seeing from a scale perspective is very fast. In 2030, for example, in my country, we have clearly ambitions. In 2050, we are carbon emission free. And there are many other countries which are going along this path. In order to do this achievement, there is no, in my opinion, no doubt that renewable generation will be a major player in that context. And that can be, and that will be for sure, two technologies we know a lot about, which is wind and solar. But it's also my expectations to see other technologies coming on the scene and contribute to this part of generation. Because if we look at the efficiency we can create by doing renewable generation to the end producer, this is some of the highest efficiency we can achieve in terms of system efficiency. In that context, when we are moving into renewable generation, we are also moving into an electrical world. Today, if we look at the energy mix, this is really fossil fuel based, but in my perspective, the world will be electrical based. So the electrical market, the electrical system will be the full backbone of a huge number of, let's say, energy transitions and solutions of the future areas. And I think that's worth to have in mind when we are talking about how we are building infrastructure, but also when we are thinking about how the interplay will be between selling and buying energy. In that context, one of the main reasons, in my opinion, that it makes very big sense to go electrical is that one of the most efficient way to do transportation is electrical vehicles. If you look from generation to, let's say, energy on the wheels. And this transition, even if I look in my own country, 2 years ago, nobody was buying electrical cars or electrical based cars. 2 years ago. The last report on which cars were sold, as 2 years later today, in November month, it was plus 50%. So this is totally fundamentally changing, let's say, the transportation sector. And I would expect that this is maybe close to 100% in 1 year. So the fossil fuel cars will be phased out very, very fast. And that demands, of course, electricity generation. Then I also will highlight energy carriers. They have to work together, not only electricity, but we also need heat, and we need gas in some situations, or other kinds of fuels. In order really to solve the big challenge, the digitalization is important, and that has also been mentioned before. So we have to master this discipline and understand this discipline to make things working together. And that can be control of the energy, that can be the grid, that can also be the manufacturing industry and so on. And we should take the, let's say, the possibilities which are there because of the digitalization, because there are a lot of digitalization possibilities, but also threats in terms of security, which we have to be aware of. And then last, I will maybe say that every joule saved at the end is also saved at the generation. So we have to do a society which are more energy efficient. So every place where we can come up with technology which are more efficient, this will also be gained at the production side. And then, of course, at the end, I would also say, looking at the program here in the next 2 days, we should always look at smart new ideas. And that is the reason we are having a conference like this. Not only stick to our traditional way of thinking, but also open up for alternatives to see what could that make a difference in terms of changing the world's energy mix and also reduce the carbon emission. So what I expect from you, the idea here is, of course, is the young, you are the young generation. What I expect from you is to be the next leaders in order to make this transition. You can listen, when you listen to my biography, I'm not so young anymore. So you are the next generation. And you should also create the next ideas. You should do the implementation, but you should also come up with, let's say, the next generation to take over and solve the global challenges we have here. At the end, I would especially thank all the organizers for setting up this conference. It's not easy to do, but it seems to be a very strong program with a lot of inspiration. So I will thank you very much for the university, for the committee, and who else are involved. And then I wish you all participants a very, very nice and inspiring conference the next 2 days. So thank you very much.
Thank you, Mr. Blaabjerg, for your magnificent speech today. For our young generation, I think we will be very inspired by your speech today. And of course, stay with us for our conference days. And for the next speech, we are welcome to Federico Rosei from Institut National de la Recherche Scientifique from Canada. If you are with us, please connect to our online conference. We are waiting you.
Привет. I am pleased to share some thoughts with you, and I'm sorry that unfortunately I'm not able to be with you in person on this occasion. Hopefully in the post-COVID era, I will be able to visit Russia and will be able to meet you all in person. So I will share my screen as I have a few slides that I would like to share with you. These are introductory slides about essentially the role of energy in sustainable development. First, the question is whether sustainable development is even possible. As far as I'm concerned, sustainable and development are two words that don't go well together. Let's take a look at the United Nations definition of sustainable development: meeting the needs of the present without compromising the ability of future generations to meet their own needs. In the past several hundred years, we have done exactly the opposite. Now, the United Nations have essentially come up with a list of 17 so-called sustainable development goals. These are grand challenges that need to be addressed for a long-term peaceful coexistence of all living species on the planet. I took the liberty of rewriting them and underlining the ones that I believe we as academics can realistically address or contribute to address. Number 3, good health and well-being. Number 4, quality education. Number 6, clean water and sanitation. Number 7, affordable and clean energy. Number 9, industry, innovation, and infrastructure. Number 11, sustainable cities and communities. Number 12, responsible consumption and production. And number 13, climate action. But I can actually, from my point of view, reduce these 17 to a smaller number, what I call the simplified SDGs. And these are energy, education, health, food, environment, sustainable production, and consumption and production. And it turns out that they're all interrelated. So the choices we've made, the type of energy we've used for the past 200 years have actually had a detrimental effect on the environment as well as on human health. So the choices we make, in fact, have a direct consequences on everything that happens on the planet, good or bad. And in this respect, I maintain that of the 17 sustainable development goals, or even of the 6 sort of simplified ones, the energy challenge is the most important and the most urgent one that we need to address. So this view graph contains 2 pictures that are borrowed from Physics Today from about 15 years ago. They're still remarkably sort of up to date, so to speak. So if you look at the graph on the left, it gives you the breakdown of energy sources as a function of time. And the prediction for this year, 2021, was quite accurate. About 85% of the energy we use derives from fossil fuels. A few percent is nuclear, a couple of percent is hydroelectric, and all the other renewables, solar, wind power, geothermal, tidal, etc., they're all lumped into this generic biomass and other, and these are only about 10-something% total. So the challenge here is pretty big. We have to replace more or less 85% of the energy we use with alternative and mostly sustainable and renewable clean types of energy. The graph on the right, well, this gives us an additional input. It tells us how world population has been growing as a function of time. At the moment, it's 200,000 people per day, which means 70 million new people on the planet every year. That's roughly twice the population of Canada, the country where I live, or roughly the population of Italy, the country where I was born and grew up. As you can see, if we go back a few hundred years, world population was much, much smaller than it is today, and it was growing very, very slowly. It's in the 1800s that we've seen this sharp rise, so that this curve of world population as a function of time looks incredibly like an exponential curve. What do we know about exponential curves? Well, it's the fastest rising curve in mathematics. There's nothing that grows as fast as an exponential. And it all started in the 1800s, which is the era we refer to as the Industrial Revolution, but it turns out that the Industrial Revolution was powered by coal. That is the first fossil fuel that humanity used on a large scale. So there's another aspect, of course, of energy, and two other aspects. One is that we waste a lot of energy, of course, but the other one, which is even more daunting in my view, is that not everybody has access to energy. If you look at this map of the Earth at night from satellites, well, in the northern hemisphere, we actually use and waste a lot of light and therefore a lot of energy at night. In the southern hemisphere, not so much. And you can see there's entire regions, huge parts of continents, South America, most of Africa, Central Asia, they're dark. It means there's no power, no electricity. How many people live in these conditions? Well, it's not entirely clear, but probably about 1.5 to 2 billion people. So roughly 20 to 25% of the world population do not have access to energy. And these same people, well, you can imagine they also don't have easy access to sufficient food, clean water, sanitation, jobs, etc. Now, going back to the slide that I showed you earlier about the consequences of using certain types of energy, well, we can summarize this by citing a concept of sustainability trilemma. So there's three competing forces: energy, the economy, and the environment. The type of energy we use can be beneficial for the economy, in which case it damages the environment, or it can be environmentally friendly, and the argument has been so far that in that case it will damage the economy. Of course, this still ties into world population and the fact that more people obviously require more energy, more food, more jobs, more clean water, and so on and so forth. So as long as population keeps growing so drastically, it will be next to impossible to find technological solutions to address these challenges. Now, we work on various aspects of energy. The primary one for us is energy conversion, mostly looking at a variety of solar technologies in which we're trying to capture as many photons as possible from the net intensity distribution that comes from the sun and convert them into other types of energy. If we look again at the map of the Earth at night from a satellite, we can invert it and look what it's like during the day and call it a map of possibilities, because the same areas that are dark at night are the ones that have most sunshine during the day. So you can imagine that it should be possible to deploy essentially solar technologies in these parts of the world, and they would have a huge local impact, probably within 1 or maximum 2 generations. Here we mostly focus on photoelectrochemical solar cells that mimic the photosynthesis reaction in plants. Essentially, they convert radiation to a form of chemical energy, and they have certain advantages and disadvantages. Among the challenges, their efficiency and stability are limited, but they have huge advantages because they're fairly inexpensive and they're low energy intensive, which means that you don't need a high energy budget to actually fabricate them, which means you're not going to emit substantial carbon emissions during their fabrication. We also work on materials for energy saving, as you see here, the historical perspective. About 200 years ago, we were essentially burning oil, gas, or kerosene. Then the incandescent lamp or the light bulb was invented. And then going through several steps, we're now in the era of solid state lighting. And this concept is really fantastic because LEDs save substantial amounts of energy and therefore money, and they also reduce drastically carbon emissions. Materials for energy storage. Now here you see this view graph, it's a little bit outdated. At this point, you do find vehicles for which the electrical charge makes them competitive with traditional gas-powered vehicle in terms of the autonomy of the gas tank versus the autonomy of the battery. The problem remains, though, that it takes much longer to recharge that battery than to fill up your gas tank, of the order of hours as opposed to minutes. And so this is a huge drawback. There's another aspect we have to consider, that all renewable energy sources are intermittent, and therefore the challenge that is common to all of them is storage. So storage is, for the moment, one of the main hindrances to deploying renewables on a large scale. So here you see sort of how I view the future, so to speak. We're talking about energy, but my background is material science. Looking again at the trilemma, the sustainability trilemma, a certain number of sustainable development goals. Essentially, materials are key to any potential development that is sustainable or not. They're at the core of any technology. They determine performance and cost. And quoting Kobayashi, those who control materials control technology. So I guess you probably didn't learn much in this respect, but let's say that if you were not fully aware, we are facing an energy crisis. Now, the word crisis comes from ancient Greek. In English, we give it a negative connotation, but in its original meaning, essentially, it was a divergence of paths or choice. One day I asked a Chinese colleague, how do you say and how do you write crisis in Chinese? It turns out that it's a composite character, two characters. The first one means danger, and the second one means opportunity. So in this respect, we are, in fact, facing a crisis, a divergence of paths in which we have to make a critical choice. Either we continue with fossil fuels, which places us fair and square in the danger zone, or we choose the opportunity of merging towards renewables. We phase out fossil fuels as fast as possible, something that we used in the past, but that it's not going to determine our future. And I also want to share with you an ancient proverb from North America, from the ancient people of North America. We do not inherit the earth from our ancestors. We borrow it from our children. We have to make sure, when we talk about sustainable development, we have to make sure that the legacy we leave behind for future generations is at least as good as what we inherited from previous generations. And I'd like to acknowledge, have a debt of gratitude to the funding agencies that support us and the industrial partners, as well as collaborators and trainees. I've had more than 180 trainees from 42 different countries, including Russia. And once again, as I mentioned earlier, I hope one day we can meet in person in a sort of post-pandemic era in which traveling will become easier than it is now. I wish you a wonderful conference. Spasiba.
Dr. Rosei, thank you so much for your very interesting presentation. We really enjoyed it. And I would like to say thank you once again for Dr. Blaabjerg and Dr. Rosei. I know that both of them will join us all 2 days of the conference, and it's a really honor for us that such great professors will join us and will feel interest in all our presentations. So
now we turn to our plenary speakers, and we are pleased to welcome Professor Yongheng Yang, professor at Zhejiang University from People's Republic of China, a recipient of multiple awards, among them the 2018 IET Renewable Power Generation Premium Award and the 2021 Richard M. Bass Outstanding Young Power Electronics Award from IEEE Sustainable Energy System. He's currently serving as the Secretary of the Technical Committee of Sustainable Energy Systems and as a council member of the China Power Supply Society. Dear Professor, you are welcome.
Hello, can you hear me?
Yes, we can.
Yeah, I had a connection issue previously, so I reconnected. Yeah, great. So thank you so much, and it's my great honor to present our recent work at this conference. My name is Yongheng Yang, and thanks a lot for the kind introduction. Today I will talk about active power control of smart PV systems for grid support. And I'm now working as a ZJU 100 professor at Zhejiang University, China. So about today's presentation, and first I will go through the background and motivation why we are doing this work, and then I will introduce this active power control for smart PV systems. And we name it as a virtual energy storage because we sort of operate in the PV systems like an energy storage systems. Then I will briefly give 2 examples of PV systems to support the grid in terms of frequency regulations. And then I will conclude this presentation and to have some discussions with you all. Yeah, we all know that renewable has experienced an exponential growth in the past years. This slide basically shows the past 2 decades, how renewable generation or renewable installation has been growing in the past 2 decades. As you can see, compared to hydropower, solar and wind has accounted for a quite big portion of renewable generation capacity. And with respect to solar PV systems, this slide shows the global installed solar PV capacity until 2020. As you can see, the accumulative capacity of solar PV systems is now more than 700 gigawatts. And in the single year of 2020, there was more than 120 gigawatts PV installed across the globe. This is a significant increase, and we would expect more in the next few years, because we still expect grid friendly and environmental friendly generation systems. We are still ceasing down or stopping this fossil fuel based power generation. And with respect to our solar PV generation systems, the energy conversion or the power conversion is like shown in this slide, this figure, and it is based on the photovoltaic effect. Then we have the power generation that is dependent on the ambient conditions. And this generation is DC direct current power generated by the photovoltaic panels. And if we wanted to connect it to the grid, of course, we need power converters. That's the intermediate stage to realize the power transfer and to condition the power from the DC to the AC grid. And the other thing is when we connected solar PV system to the grid, we also need to synchronize the power with the grid in terms of the frequency and also the voltage amplitude of the generated power from PV systems. And as I mentioned, because solar PV generation systems are highly dependent on the operating environment or the operating conditions, supposing we have a quite cloudy day, then the power generation from the PV systems will fluctuate significantly. Then if we consider a high penetration degree of solar PV systems, this high fluctuating power injection into the grid may cause unbalance between the generation and the demand. Then we may experience frequency stability and voltage stability at the grid side. So in conclusion, and if we integrate more solar PV systems, this is a double-edged sword. Now you have to consider in the system design and also in the control of the entire systems. So with that, if we wanted to integrate more PV system into the grid, there are increasing demands we have to follow in terms of grid integration of PV systems, ranging from several kilowatts to even a few megawatts. PV systems. So the PV system must comply with a much tougher requirements than never before. So it is a combination of standardized PV features with advanced demands for a grid-friendly integration. For example, our PV system need to flexibly regulate the exit power. They also need to provide reactive power to participate in the voltage regulation. And as I mentioned earlier, in terms of frequency regulations, your PV system need to flexibly control the active power. Beyond those, your PV system also need to compensate harmonics or to control, to manage the harmonics in the entire systems. And in terms of grid faults, then your PV system need to provide dynamic grid support. For example, low voltage rise through with reactive power injection in order to help the grid to quickly recover from the fault mode. Anyway, there are increasing demands and requirements on PV systems we have to follow, and this fortunately can be achieved by proper control of the power converters of PV systems. So in terms of active power control, in the past, the PV systems are seen as a purely power generation unit, but not today. It is not just a generator. PV systems should be more active in grid regulation. In the past, we focused on maximum power point tracking of PV systems, but today, new demands for grid integration has been imposed on PV systems in terms of active power control. Your PV system need to perform flexibly the regulation of the active power. For example, constant power generation, delta power generation control, and also power ramp rate control of your PV systems. So with that, we would like to introduce this flexible active power control, also referred to as virtual energy storage operation of PV systems. But before we touch on the control of PV systems, let's briefly review the PV system configurations. And depending on the power rating of your systems, it can be generally categorized into 3 groups. The modular level PV systems, which means you integrate your PV panels through module level converters like DC optimizers and AC microinverters. If you put your PV panels in series to form PV strings, then you can adopt these string inverters. And in between the PV strings and the inverters, you can also add DC-DC converter to increase the controllability of the maximum power of your PV systems. And if you further scale up the power rating of your PV plants or PV systems, you can adopt these centralized PV inverters then to connect it to the grid, as shown in this figure. And as I mentioned, the PV systems have to comply with various grid demands or requirements. And for example, basic control like maximum power point tracking, and your PV systems also need to synchronize with the grid voltage through phase locked loop or frequency locked loop. And in terms of grid faults, your PV systems has to provide grid support to write through voltage faults, and also your PV system need to provide power quality regulations, harmonic compensations. As I mentioned, all those demands can be met by properly controlling your PV power converters. And this is straightforward because the power converters, the DC-AC inverters or the DC-DC converters are the only controllable unit or equipment in the system. So today we will walk through this flexible active power control, how this can be done by control the DC-AC inverters, then how this can provide frequency regulations from the PV systems. Yes, and to regulate your active power from PV generation systems, then you can, of course, to integrate energy storage. And this is the most straightforward way, and this is also the most flexible solution. But of course, when you adopt energy storage devices, the overall system cost is increased, and your control complexity is also increased. Another solution is that you can adopt dummy loads, which means that you can dissipate the power or the energy to the loads when you need to regulate your active power. But of course, this is not a universal solution. It significantly depends on the system configuration, and also it is limited by the loading conditions. If the loads are not available, then you can't regulate your active power. And the third solution is also depending on the system configurations. It is designed for multiple units. You can switch in and out different units, PV units. Then you can regulate the active power from the entire PV systems. So when you switch in and out the PV generating units, you may challenge the entire stability of your systems. So this is not very viable solution seen from the global stability perspective. So with that, then we propose the solution, which is called flexible active power control strategy, or flexible power point tracking, in short, FPPT control. And it does not require any hardware modifications, and it is easy to implement. And more importantly, it is an universal solution to all PV systems. So you can simply modify your software, modify your control algorithm, then you can achieve this flexible power point tracking. And but of course, it has some drawbacks, and it is a unidirectional solution, which means your PV system cannot provide additional power more than the maximum available power. So this figure basically shows the general control block diagram of these systems. As you can see, we modify the maximum power point tracking algorithms to achieve this flexible active power regulation. And this figure further shows the operating principle of this FPPT control strategy. And we compared to the conventional operating modes, we move the operating point from the maximum power point to flexible power point 1, either FPP1 or FPPT2. Then in this respect, then you sort of reduce your active power, then you regulate your active power from your PV system. And when we do a comparison with batteries, then you can see if your PV systems operate at the flexible power point 1 or flexible power point 2, you sort of have this virtual energy then discharged. And if you further lower the operating point, for example, at this point, then you are charging your batteries. That's why we call this flexible power point tracking operation as a virtual energy storage operation, because we don't use physical storage devices in the systems, but it can be operating as energy storage devices. So the first active power control strategy I would like to introduce is this constant power generation, which is also referred to as power limiting control. And there are also a couple of solutions to achieve this operation. Either you can directly limit the power from your PV modules, or you can limit the current from your PV panels, but all those are not very feasible in practice. Then we adopt this flexible power point tracking control. The principle here is if your available power from the PV panels is higher as a setting point, the power limit, then your PV systems generates the power exactly at the power limit as a constant. And if it is below the power limit, then your PV systems operate in the maximum power point tracking mode. Again, like a battery energy storage, above the power limit, the PV system is operating in the discharging mode, and under the power limit, your PV system is operating in the charging mode. And this slide further shows the operating principle of this power limiting control using this PV power voltage curves. As you can see here, then we move the operating point either to flexible power point 1 or flexible power point 2, and to retain the output power as a constant. We have done some experimental tests under 2 daily profiles of PV systems. The rated power is 3 kilowatts, as shown in this slide. Under a clear day, we sort of limited the power output at half of the rated, which is 1.5 kilowatts, as shown in this figure. And under the cloudy day, we have set the same power limit, 1.5 kilowatts. And with our flexible power point tracking control algorithm, we can achieve this power limiting control properly. And another active power control strategy I would like to introduce is this power reserve control. Why power reserve control is needed? Because in today's power grid, we are using a lot of inverter-based resources, and all those inverter-based resources are inertia-less systems or low inertia systems. Then we may encounter frequency stability in the entire systems in the case of large load changes. So in that sense, we have to reserve a certain amount of active power or energy in order to provide frequency regulation when it is needed. So for this power reserve control, we can also use the flexible power point tracking control algorithms, but in this, the power limit is not a constant, but it is changing with the change of the available power from your PV systems. So to illustrate this concept, we also used the PV power voltage curves as shown here. Supposing your PV system is operating at the lower solid irradiance level at this point, then when the power reserve command comes, then your systems will operate at the FPP1. Then if the solid irradiance level changes, then your systems operating at this point, when the solid irradiance changed again, then your PV system operating at this point. In all, then you always have a reserved power of delta P. So when you have this delta P in this region, if you time this reserved power with a time window, then this is energy. So we can use this sort of energy to provide frequency support to the grid. So the challenges to achieve this power reserve control is that how to measure available power. There are also a couple of solutions. For example, you can install solid irradiance measurement devices, or you can use artificial intelligence techniques, or you can apply curve fitting method. But all those, either you increase the hardware cost, or you have the performance may be degraded along with the long-term operation of your systems. So with that, we introduced 2 methods. The first one is called the master-slave power reserve control. We employing a small PV unit to operate in the maximum power point tracking mode to estimate the entire PV system output power. Then we adopt the rest of the PV units to operate at power reserve mode. The second solution is we adopt a hybrid operation between the maximum power point and the tracking power reserve control mode in one single PV unit. Then we can achieve the power reserve. So today I will show the example of a master-slave power reserve control as shown in on the 2-stage PV systems. One PV unit is operating as master string to estimate the available power. The other is operating at the power reserve to reserve the power, then you will see at the grid side, and the output power from your PV system has a certain amount of power reserve. We have also done an experiment test on 2-string PV systems, and under clear day and cloudy day, the target of power reserve is 200 watts, as shown here. Then we under clear day and cloudy day, both we have achieved this power reserve. Yeah, this the above I have introduced these active power control strategies, 2 examples, and then with those 2 examples we can provide frequency support for PV systems. And to recap the virtual energy storage operation, when your PV systems is operating lower than the available power, then above this power reserve point, your systems can release the energy to support the grid frequency. Or if you further lower the operating point, you are sort of storing more energy. When the frequency event is severe, then you can release this energy to provide frequency support. More specifically, if you have an over frequency issue, your PV system can reduce the output power. If you have an under frequency issue, then your PV systems can increase output power. Then the solution here is like what I have introduced, this power reserve control. Then with that with the power reserve control, we can provide inertia support from your PV systems. This compare the PV system with and without virtual inertia control by utilizing the reserved power from your PV systems. So on the left-hand side of this experiment test, that's the PV system without virtual inertia control. And on the right-hand side, that's the PV system with virtual inertia control. And when you're comparing the 2 results, you can see that when you adopt this virtual inertia control through the reserved power, you can improve the Rossikhin performance and also the frequency nadir of your entire grid. Then the other thing is when we have the frequency regulation trajectory or the regulation curves, as shown in these slides, we have to consider some critical indices of frequency quality. For example, the frequency nadir, the rate of change of frequency, the Rossikhin, and also the steady state frequency deviations. So when your PV system have the reserved power, you can sort of manage or optimize your reserved power or your reserved energy to sort of to optimize your frequency quality. We have done a simple study, simulation study, and to see how the inertia constant and the damping gain will affect the frequency quality of your entire grid in terms of the steady state frequency and the Rossikhin as shown here. Then we can conclude that before the frequency nadir, you should expect a large frequency inertia constant, and after the frequency nadir, we expect a large damping gain in order to bring your frequency as close as possible to the nominal frequency. Now with that, we proposed a hybrid control strategy for PV systems, and also we compared with other solutions like a fixed damping gain and fixed inertia constant. And the simulation results are shown in this slide as shown here. Then when we compare it to the other solutions, our proposed solutions can improve the frequency quality of your entire system. Yes. To conclude today's presentation, and first of all, then we know that PV is a still booming area, and further high penetration of PV systems will challenge the entire power grid. But of course, then we need to develop advanced control, and grid-friendly strategies are necessary. And today we have introduced this active power control strategy, which is also called virtual energy storage operation control. And then this can enhance your PV systems in terms of the grid integration performance. Yes, with that, I would like to thank you all for your attention. And if you have any questions, I would be happy to answer and discuss with you. Thank you so much.
Dear Professor Yang, Thank you so much for your very informative presentation. And now, are there any questions from the audience or from the Zoom chat? Alexander Parin, do we have some questions in the Zoom? I guess.
Hello, colleagues. Now we don't have.
Are there questions from? We will gather all our questions and then we will send you a mail with the questions from the audience and from the Zoom chat.
Okay, that's great. Thank you. Then I hope you have a very successful conference. Thank you.
Yeah. Thank you very much. Thank you.
Thank you, Professor, for your very informative speech. And now we're ready to invite our next speaker, Daria Podmetina, Associate Professor of IM Lud University in Finland. She serves as a principal investigator in various projects, such as sustainable services for the future and innovation capacity building for enhancing sustainable growth and employability. She's an author of many scientific publications on entrepreneurship and innovation. Dear Professor, your timing for your speech is 12 minutes plus 3 minutes for possible questions. Thank you so much. Welcome. Your microphone is not on. All right.
Yes, I can see. Thank you very much. Thank you for the organizers for the invitation, and very welcome to all the conference participants. Let me just start the presentation. Yes. Okay. So I represent the Lud University in Finland, so which is not very far from St. Petersburg. So we are just across the border by the beautiful Saimaa Lake. And we are proudly holding the green campus status because we are in the forest and we are very much following the sustainability and the green energy rules. So if you come to visit our campus once, you would see that we are equipped with the solar panels and windmills just around our buildings. We also follow the principles that the clean energy, water and air are the life-giving resources to be cherished, and at the Lud University we are seeking new solutions with all of our expertise in technology and business. So at Lud University we are combining community of altogether 6,500 people, students, teaching personnel, support personnel, and much more. So altogether the campus is very international, and from our faculties, we have a faculty of energy, we have faculty of engineering science, we also have a school of business. So our research and teaching are focusing around these three areas. And in all of the areas of energy, air, business, water, managing the water resources as well, we are following the principle of sustainability. So that's why sustainability became one of the main areas to be integrated in all of our research projects and our teaching activities with students. That's why I was asked to share some of our experiences, and I decided to choose one of the courses which also integrates technology, including the energy technology and the sustainability in its curriculum. We developed this course within the effort project, and if you are interested to check, there would be the link provided on my slides. Which will be shared with you, and this project is focusing on the developing tools, instruments and guidelines to support the teachers and increase the effectiveness of teaching the sustainability in the different areas, of course, in engineering and in business. So we are focusing on tools how to evaluate the impact of the courses on students' knowledge. We also looking for new innovative teaching formats, and we are collecting and will be distributing also, of course, in the open space, a handbook including the several different teaching formats focusing on the sustainability. Among the new approaches we identified and actively apply now in teaching, such as experiential learning, practice-based learning, collaborative learning, flipped classrooms, and many more. And we are looking for more student involvement and more interaction with students, and more put the practical cases and make the students to do solutions, provide solutions for the cases, and to come up with some new skills and abilities to become a professional in the area of specialization. So what we chosen for this course specifically, we actually went to the STEAM approach. The STEAM is usually the arts in integration into the STEM courses, the hardcore courses in engineering, and management also supported with some artistic methods. And here we went with a theater-based teaching. Of course, if the course was piloted in the spring 2021 under the heavy COVID pandemic, so we had to turn our theater performances into the movie performances, but this was another challenge we had to solve. But anyway, we took the theater-based teaching principles, and because they are very much facilitating the understanding of the difficult technology concepts, they also develop the students' expression capacity, interpersonal communication, and empathy, and also provide a suitable framework for exploring the future scenarios. So we piloted this model on just 20 students at Lut University, and as I mentioned, in the COVID time, it was completely online. It was challenging for both students and teachers, but I think that we all had quite an interesting experience. A few more words about this and why and how we implemented that. So we found out that analyzing the technology, and not just technology, but any innovation in the complex of context of sustainability is very similar to the structure of the book, play, or a movie, because it's a story. In every case, technology development, innovation, this is a story told by a company, or a movie played, or like a performance done by the team of professionals. So it's very much there exists accompaniments of the script, like an exposition, a rising action, then the climax and failing action, and the final outcome, hopefully with a happy end, which not always happens. Such examples were used in our course. So for example, students were narrating the trajectory of innovation in such areas as meat grown in the laboratory, or platform economy, or applying the biofuels. So there was no any limitations what kind of technology students would like to consider in their final report. So we didn't put any limitations. We just were discussing a variety of technologies which are very important for development of a sustainable future, which have either risks for the sustainability, as mentioned by Professor Rosei before, or an opportunity for solving the sustainable problems. And to solve that, I would like to quote Benjamin Franklin, who told that, "Tell me and I forget, teach me and I remember, involve me and I learn." That's why these methods worked much better with the students and solving specifically the objectives of this course, which were focusing on increasing the awareness of the problem, technology problem, and sustainability issues, to making students understand that there is always sustainability is going along practically with any technology development in any business process, which needs to be acknowledged and integrated into the solution and decision-making process. Also, we wanted to show the complexity of the sustainable technology development and its effects on the society, and envision and work towards the solution of the grand sustainability challenges. The course included several weeks. We used Moodle environment, and we had a very clear structure. We had pre-recorded lectures. For example, on this week 1, there was a understanding of the basic concept of sustainability, and then students had to write a short essay expressing emotion based on some real environmental or societal sustainability issues, sustainability problems, what concerns specifically them, what touching them. So what makes them feel uncertain in the society and what they would like to solve in the future. So following this, going more in depth into the sustainable innovation, we were discussing sustainable innovation in manufacturing in the different industries. We also put our focus on the responsible innovation. And here we introduced students to technologically oriented topics which can be argued to about the sustainable development goals, but implemented in the business and society. So, for example, platform economy, lab-grown meat, biofuels, robotics, and automation, our energy and other energy processes, and etc. And students had to start to think about their project. Along these theoretical foundations, we were also making the seminars with students, explaining how to write a script, how to perform, how to record a video, and etc. So how to wrap it up in the theater performance. We followed with the ICT development and sustainable development and impact assessment, and solving the real cases with students. So in this case, we had our rescue club, local company, who created the idea and very successfully implementing to sell remains of their buffet lunches. And it sold out right away. So people in internet are voting and getting them, picking up this food from the restaurants in the city. And the restaurants don't have any remains. They don't need to throw food anymore. So which is very popular in the local community. We are using it like almost on the daily basis to get some food for home. We also included the topics such as sustainable society, not only based on the lecture, but on the TED Talks, for example, and students reading articles on the specific topics. And meanwhile, as the course evolved, students will also continued working on their plot development and preparing for the final performance. We also had a game to introduce them the different stakeholders in affecting the technology development and the sustainability, and to try to draft the roles of the different stakeholders in this process. So we also touched the topic of ethics and sustainability and technology, and I was in charge of this part, and I have a lecture on this ethics and sustainability, and I put it in the framework, putting into the core concept of, the African philosophy of Ubuntu. We are, I am because we are. And along these classes on the ethics, we were working around this concept to be integrated, importance to be aware of other people, to be integrated, to be involved in the community, to be involved in the society, and work for the common good. The course proceeded with disruptive technologies for sustainability, also focused on the renewable energy, blockchain, and the overall role of technology for the sustainability. And here we already going directly to our Grand Movie Festival. We would have a beautiful theater performance if we would be allowed to. Now we have a very nice scene and auditorium at university where we usually do our big celebration, big events. But we had to do it online, and our students presented their stories on the different topic related from the varying from the energy to sustainable consuming and clothing and the food, of course. So that was a very interesting event, and we got rather positive feedback. So students enjoyed such a format of teaching and learning. So we are happy to share the thoughts and ideas with you, and this you will have this presentation. If you have any questions or comments, please, very welcome. Thank you very much, and I wish you very successful conference and very productive networking and new ideas for the research and teaching.
Dear Professor, thank you so much. So do we have any questions in the Zoom chat or the audience, dear guests?
Good afternoon. We have a question first to Daria. What were the corrections in the course structure due to the pandemic? Any new chapters or any changed implementation format? Thank you very much for your question. As I said, the course was piloted for the first time during the pandemic. We developed the course for regular class format, and we planned to have sessions as teaching theater, and we wanted to teach our students how to best present their ideas or their projects, and we would have used the theater as a means of presentation, but we had to move online, and students shot movies instead of theater performances. We watched videos. That's how we adapted the course for pandemic, but it was a successful adaptation.
Thank you. Any other questions? If we will have questions, we will write you an email, okay? Thank you so much.
Спасибо большое. Thank you very much.
And now we have some questions from the Zoom chat for the previous professor. Alexander, you're welcome with questions.
Thank you. Indeed, Roman Tsarigorодtsev asked a question. What about disposing of PV system, photovoltaic system?
Mr. Yang, you can connect to us and answer for the question.
Yeah, I'm connected. So
yeah.
What was the questions? Yeah, I received through the chat. Alexandra said that there was a question related to how we'll be solving the issues of recycling PV systems. And I think, yeah, well, it is a very good question. Yes, and the recycling of PV panels is an issue. And when we look back to the development of PV systems in the past 2 decades, and by 2020, as well as the next 10 years, we will expect many retired PV panels, because those panels or those PV systems installed 20 years ago, they will soon reach the end of their life. So how to recycle is an issue, and to my understanding, there are several projects, I think in EU as well as in China and in the States, and also there are a couple of companies actually working on this. And we know that the easiest part to recycle is to simply disassemble the panels, and the metal frames and the glasses can be recycled directly. But for the silicon materials of the PV panels, the PV cells, I think the current technologies are still very costly. So compared to recycle the silicon materials of retired PV panels with manufacturing new panels, the cost is still high. So in that sense, currently the technology is not mature yet, but maybe in the future we will have some simple and affordable technologies to recycle everything. I mean, all the materials of PV panels. Then we can, of course, to use and to recycle all the stuff. But the other thing is, instead of recycling all the materials of PV panels, we can maybe we can rethink or to reuse the panels, because when the panels reach their end of life, they can still produce power with a lower efficiency. We can still develop novel solutions through novel power converters to maximize the power from those degraded modules. Then those degraded modules can be used in combination with normal modules. Then you can sort of lower the entire PV system cost. This is also another way to reuse or to recycle the PV systems. So I hope I have answered your questions. Thanks a lot.
Thank you so much. Thank you, Professor Yang. And now I know that we have a question for Daria Podmetina from the Zoom chat. Alexander, you're welcome.
Yes, we have the question from Fatou Mashalaba, and the question is this course part of a degree or it is an individual course? Thank you.
Okay, thank you for the question. Yes, the course is a part of the several degrees at LUT University. We have a little bit different structure here. So it's included into the one program in technology management and one program in I think in energy. Also students are attending this course, but it's not like a compulsory, it's one of the elective courses for students.
Thank you so much. Thank you, Professor Daria Podmetina. And now we have another presentation.
Yes, thank you very much. We are ready to invite our next speaker, who is Robert Szydlo at the Krakow University of Economics, which is the biggest university of economic sciences in Poland. His latest research has been published in the first quartile journals named Energies and Sustainability. Dear Mr. Szydlo, you're very welcome.
Thank you very much. Can you hear me? I want to make
we
sure.
do.
Perfect. So ladies and gentlemen, first I would like to say thank you for organizers for preparing such an interesting conference and give me this possibility to address my topic, which is kind of a second side of what we've heard a few minutes before, because me and the team that I was working with my distinguished friends from the Department of Labor Resource Management, is connected with employer expectations to our competences on the energy market in Poland. So this is kind of a second side of the education topic that we've been listening so far. So I'm not gonna probably take much time, but still for the energy sector in Poland, we've managed to find three main topics. So first of all, for Poland, and I think for every country, energy sector is a key one for security and the development. So without that, the whole life in the country would simply be seized or stopped in a very fast way. The energy sector is growing annually, both in the whole world and in each every countries in Europe, same as in Poland. And what is interesting for us, this renewable sources increasing their importance. So all the energy from the air, from the solar systems, well, with the percentage of the energy from that, it's still increasing. But this is just the background for our research, because my team is mostly focused on competences. So basically for all those facts, apart from intelligence, that maybe actually a good predictor of the work results. And as Bayatsis introduced and connected competencies with the labor market with the term of employability, those competencies, I think, or we think that's even more important for every sector. So to be honest, if the fuel and energy sector is still growing, we are talking about young engineers on the sectors. So basically the competences, the importance of the competences rises. And many international institutions, higher education institutions, are trying to shape the employability of young engineers. They're trying to raise the competences in various ways, and as we heard, very innovative ways as well. So we decided to ask two research questions. So basically, what are the needs of competences in the Polish energy labor market? And what is the structure of hard and soft skills, so-called, within this labor market? And for what we decided to do, it was not a questionnaire sent for the companies, because this declarative approach may have some misleading information. So we decided to analyze the job offers that all four main players the Polish energy market revealed to the potential candidates, those job offers, both on their company sites and in a specific recruitment portals. So together in around 2 weeks between May and June this year, we managed to find 245 different job offers for mostly young engineers from the energy sector in Poland. And for the statistical results, we've been using mostly the SPSS software. So what are the results of our, what are the findings of our research? First of all, we've indicated like 153 different competencies that companies require from students, which is a huge number. And of course, not all of them are in the same level of demand. So here you can see those competencies that appeared in more than 20% of the whole job offer. So mostly the teamwork, 126 indications in the job offers, and very similar Microsoft Office and this back office software systems. They are in the highest demand. Of course, we have also organization of own work, communication, analytical thinking, and actually for very typical engineering, like those hard skills, electrical qualifications and certificates were also highly welcomed, although only in 23% of the job offers. We decided to conduct this exploratory factor analysis to indicate the groups of competencies, because 153 of them was actually too hard to analyze in a correct manner. So we revealed 8 different groups of competencies. So basically, what companies requires? First of all, we have those intrapersonal competencies, all those connected with a person as a single entity. So we have this analytical thinking among them. We have this eagerness to learn and to develop more, and so on. And as we can see, one of competencies from this group appeared, basically 3.7 competencies, from this group appeared in every job offer. We have the IT skills, all good with usage of computers, mobile technologies, mobile and online communication, working with people. It was at least one competency from this area in every job offer, and then working in machines, which is basically focused on operating sometimes very complicated machines, and the least important, also working with documents, including formal documents from the office perspective, as well as all the instructions and procedures for technical work. So as you can see from the means, basically each job offer contains around 9 different competences, which we may say it's quite a complex point of view. From the company's demand, we wanted to see if they require different competences, and actually our analysis revealed that within 5 out of 8 groups of competences, those companies have different needs, which may indicate that or they are on a different level, or they are focusing on a bit different activities. And that's why they demand a different labor work for them. Our second research question was connected with so-called hard and soft skills, which we divided based on our expertise knowledge from the team members. So basically, we decided to put in those certificates IT skills, as we can see here. So electric qualifications, IT, and working with the machines. Those are so-called the hard skills. The rest we've put in the soft skills mode. And what we can see here, actually, the soft skills are more required, and they're required actually more often than the hard skills, even though we are focusing on recruiting mostly the engineers. So this is an interesting fact, actually, because at the beginning we just thought that actually hard skills in this particular area, in this particular sector, will be more often required. So just not to steal time too much, the conclusions we've made. So basically, soft skills are mostly needed in general if we're talking about each every job offer, and actually the soft skills are in high demand on engineering positions. And basically, from what we observed in Poland, all these technical universities, they are focusing mostly on technical topics where the soft skills are not in such a high point of interest. And we believe that introducing more courses also based on the soft skills and teamwork, similar to the one presented by President Podmetina, I think would be highly appreciated by the labor market and by the companies. What is more, the market is not homogeneous. So basically, from one point of view, we believe that companies are on a different level of development, and they simply need different competences. In the same time, for future possible employees, for young engineers, I think it's a good knowledge because they don't have to focus on all the issues or for all the competences that might be required. They may be more specialized and be a real true specialist in a sometimes very singular topic. Basically, our research have some limitations. The short time of gathering data, we're aware of that, but it was due to the timeline of our project, that we may lack the annual trend for the competency needs from the companies. So we've covered only two sources of data gathering, which were, as I mentioned before, the company sites plus, of course, the recruitment sites. Although for some positions, there is still an internal recruitment, there are headhunters involved in the processes. So we believe that those topics may be in a point of interest for the future actions. And well, the scope is national only. So we focus on the Polish energy market, but this is not what we want in general. So for our plans, we are still searching and trying to focus on international perspective for comparative studies analysis with different countries. When I broader the scope of the research for different competencies and for especially for renewable resources. So this area is not yet very much visible in the job offers in Poland, or at least it was not visible between May and June. So we want to focus our research also for those international trends of green energy. Thank you very much for letting me address the topic. And if there are any questions, I will be really happy to answer them.
Dear Professor Szydlo, thank you very much for your presentation. It was really very interesting research. So do we have any questions? Any questions in Zoom chat? Alexander?
У нас есть вопрос на английском языке. May you clarify what competences among hard skills were analyzed?
Of course, basically for the hard skills, we've analyzed competences connected with IT sector, with working with machines, and as well as the General Electric certificates that are needed to work actually on the field. So those three types of the competences were in the analysis. And from what I remember, there were about 55 different exact competences within those groups.
Do we have any questions else? Okay, so we will gather all our questions and then we will send you by mail. Thank you so much.
Thank you.
Thank you, Mr. Szydlo. And we're ready to invite our next speaker, who's going to be the first one to deliver his speech in person. This is Ilyas Abdulkhakov, a LESI graduate, doing his research at the Faculty of Industrial Automation and Electrical Engineering, Department of Electrical Technology and Converter Engineering. Dear Mr. Abdulkhakov, you are welcome.
Hello. Let's start. I want to speak about improving the quality of power supplies through the use of intermediate pulse converters. Today, according to official data, during power transmission, the electric losses amount to 10% of the useful power. This is a lot. One of the reasons for this is the reactive power generated in the circuit. It's not difficult to show that the losses are inversely proportional to the square of the cosinus of the angle between current and voltage. An increase in this cosinus of the angle leads to a significant reduction in electric losses during transmission. Also, electrical losses are influenced by electromagnetic distortion out of the current, which is formed in the line by consumer himself. The voltage harmonic spectrum was recorded in a large industrial consumer center of St. Petersburg and shown on this slide. you can see that there is significant distortion in the harmonic spectrum.
Also wanted to say that there is a vast experience in assuring electromagnetic compatibility of devices. When the device was commissioned by the customer, it took more than 1 month for us to improve the device to get to the required parameters. We even connected the power filter, the quality one. It was then connected to the grid equivalent, which has its internal filter, and we measured the electric magnetic disturbances of the radio frequency, and they are by an order more than the admitted, so distortions are significant.
It is also known that electric losses are proportional to the asymmetry of the phase currents. Therefore, it's useful to create some kind of buffer. First of all, this buffer must close the reactive power through itself, and second, it must keep harmonic distortion of the power line. Also, this buffer should evenly distribute the power consumption over the 3 phases. And the consumer should receive electricity with the references parameters, constant amplitude and frequency with minimal harmonic distortion. This is especially true for responsible consumer groups. Let's call the buffer as a regenerator. Among other things, it will allow you to organize a distributed power system synchronizing with other sources. This regenerator consists of several subsystems. This first subsystem is an input power factor corrector, which combines the consumed electrical energy with the line. The second subsystem is a powerful pulse generator of line voltage, and its main task is to supply energy for consume. Each of these subsystems can be considered separately. Let's with the power factor corrector. The developed model is remarkable in that it uses a model of real semiconductor devices and microcircuits. For example, the output signal of the rectifier based on operation amplifier is not ideal. The chart is a comparison. Number 1 is a high frequency rectifier, and number 2 is a rectifier with poor parameters. We can see that the voltage is out of phase and even crosses the voltage 0 point. What affects the work of the wall corrector when the current value is close to 0? Its distortion is visible. By using PID controller, this distortion are increased. Also, the harmonic composition of the input current was estimated for 2 control systems. The first graph with an automatic control system and the second with PID controller. A system with a PID controller does not allow the use of the filters with a low cutoff frequency due to the resulting self-execution. And automatic tuning allows you to reduce the emitted electromagnetic interference at high harmonics.
Here is one of the most important parts.
The figure shows the dependence of the THD on asymmetry of the phase currents of automatic corrector. Number 1 is the dependence for an automatic regulator. Number 2 is a PID controller. Index A means that the measurement was carried up to 20th harmonic under the index B in the entire frequency spectrum. This is approximately 1.3 megahertz. A decrease in THD leads to a decrease in electro current in comparison with the phase current. The dependence is directly proportional, and for different control systems, the dependence differs significantly. As a rule, manufacturers are allowed to be silent about the frequencies range in which they use THD. They can also keep silent about the asymmetry of currents. If THD is about 3–5%, and this is a fairly common value, then the ratio of neutral current to phase current can reach about 20–30%. The economic effect when using such a rectifier can be minimal or completely absent. The second subsystem is a line voltage generator. The best option for its construction is a half bridge inverter for each phase with a bipolar supply. The figure shows for one phase. The use of such generator can significantly reduce the value of THD, that is even less than 0.1%. This says that references power quality can be achieved. The future is probably not far, in which the conversion of voltage from high to low will be carried out using semiconductor pull stations. Such station, in comparison with existing ones, will have a number of advantages: high efficiency, large income consuming reactive power, and maximum automation. And will also be able to cope with all challenges raised by the consumer. Today, there are no powerful high voltage devices, the class of which is acceptable for such voltages. However, their construction can be carried out by using series connected transistors with dynamic and static equalization. Switches process should be built on the basis of zero voltage switch and zero current switch methods. Such stations are easy to install and dismantle, even the difficult to reach regions of oil and gas production. Its location will make it easy to mount in any size, and the typing of models allows you to achieve maximum economic efficiency.
Let me highlight that our staff have experience of constructing high-power radio transmitting equipment with frequency ranges of hundreds kilohertz, and this task could be achieved. Thank you.
Thank you so much. Do we have any questions? Any question from the Zoom chat, Alexander?
No, we don't have questions.
Do we have questions from the audience, dear guests? Okay, we will gather then questions and we'll write you an email. Thank you, Mr. Abdulkhakov.
Thank you very much. We are going to invite our next speaker, Alexander Zhdanov, head of the Office of Technological Transportation and Special Equipment of at Noyabrsk Neftegas, a joint stock company, a subsidiary of Gazprom. And I see he has got a colleague with him. Apparently, Mr. Zubritsky, I presume. So they are going to have their presentation in person. Thank you very much. And I want to remind you about the timing of your speech. It's 7 minutes, please. If you keep it 7 minutes, that would be very pleasant for us.
Good afternoon, ladies and gentlemen. We are here to present the project title Development of Professional Competences of Young Experts through project activities based on a cross-functional Scrum approach. Here are the challenges that we want to resolve through the project. There is no systemic young professional base that would cover their competences and skills and their willingness to participate in companies' projects. The low level of youth involvement in projects, and there are no instruments to learn about projects run in companies, and there is no environment to attract students into companies' project activities, and there are no examples, there are no guidelines that would describe how company operates and involving companies' professionals and how to involve both students and mentors from higher educational bodies. These are the most important criteria when companies search for future employees, and here are the opportunities that our project offers to develop professionally, to perform interesting tasks, and to train on the job within the company. So the key non-tangible factors that motivate students, we included into our project the opportunity for career growth, to be engaged in multifaceted tasks, to be trained on the job and develop professional competences. Based on this set of challenges, and using the research outcomes, we put together the target for the project, set up a system that would involve young people in project activities of companies, and create a roster or pool of candidates with the competences and where managers can access the pool and set up teams. Students from universities can provide, through this means, theoretical support to projects, and also research at companies can be developed as well. This is the geography of young companies professionals. For these projects, they became winners of Youth Research and a Practical Conference of 2020 run by Noyabrskaya Energoneft. Currently, 6 projects are implemented at 3 country regions. So the team includes the leader, who is the project customer, and he determines targets, objectives, and outcomes. Then we have project managers. They set project tasks and approve outcomes as well as intermediate results. Curators assign mentors, and mentors provide the overall management. Together with the head of the research, they help undergraduate master students to understand the company. They set their workstations. Then university managers provide guidelines, monitoring, and heads of higher educational institutions also provide support during the project and approve project solutions, and also provide expert assessment of the outcomes. And currently, there are 12 undergraduate members of teams working on implementing these projects of young experts of the society. And here are the stages of implementations. There are 4 of them. First, search for the talented young people to set up the roster or the pool of candidates to be introduced into a staff pool roster for companies, and we plan to involve the available platforms and set up new platforms. We must work with the students of universities and create the status of young professional by posting information on external web pages and have online and offline meetings. The second stage is to present talented young professionals, experts to different level of management in the community, and we will select groups of competences like hard and soft competences, and then judging the strong and weak points of every expert, of young professional, we plan to involve them in projects as time shows that companies need a fresh look into their challenge, and of course we must care about improving the qualification of young professionals. For example, using corporate university of Gazprom Neft is one of the possibilities. Then the assessment of economics for the project. We decided to look at the aggregate economic impact of the winners from the Research and Practical Conference of the last year, because we target to implement as many projects and initiatives by young professionals as much as possible. So our project allows to use the potential of young professionals to provide vocational guidance to graduates and to create multidisciplinary teams and improve research at the company level. Dear colleagues, thank you for allowing us to present our work at your conference.
Thank you, Mr. Zanov. Thank you, Mr. Zabritsky. It was a good job, really. Thank you. Do we have any questions from the Zoom chat, Alexander? Our guests, do you have any questions? Yes, we have. So, volunteers, please.
Good afternoon. What soft skills competences are to be set up by the teams, and what soft skills are introduced by company managers, and is there a gap between soft skills that young professionals think they need and the management think they need? Thank you for your question. There is no gap the way we see it, because hard skills and soft skills are of equal value. And young people, as all of us, have strengths and weaknesses, and we want to help young people to implement their potential, but also in relation to the implementation of specific projects to tie up the skills to the project.
Any other questions? Okay, if we will have some questions, we will gather them and send you by email. Thank you so much.
Thank you, Mr. Zanov, Mr. Zabritsky. Very nice presentation. We are ready to invite our next guest, Dmitry Rossikhin, Chief Engineer at the Department of Operations and Diagnostics of Substations in one of the FGS US branches. Dear Mr. Rossikhin, you're welcome.
Timing.
The timing is, as usual, 7 minutes for your speech, plus 3 minutes for the questions. Thank you very much.
Good afternoon, colleagues and conference participants. My presentation is issues of application and development of electric power storage systems. But we will not go into the technical details in my presentation. We would rather focus on the arrangements. While energy in today's world is at the brink of changes, the way of how to store energy, distribute it, and decrease the cost is high at the agenda. Here are the opportunities that open up with having the storage systems, ESS. Electricity storage will optimize the operating models of operating plants, equalize load and store electricity for future use, reduction of CO2 emissions as a result of not using hydrocarbon fuel, higher reliability and quality, development of electric transport. ESS is a catalyst for electric transport and charging infrastructure. The priority ESS application areas, the distributed energy system, microgrids, smart grids, application of ESSC to power isolated and remote area or residential areas, use of ESS in electric transport and charging infrastructure, new master layouts for energy system, daily schedule, as well as higher quality hydrogen energy. The graph shows that the installed capacity of energy storage worldwide by 2040 will be above 900 gigawatts. The leaders of the world markets are the United States, China, Germany, and India. The development of energy storage technologies will improve the reliability of power systems. They become flexible, smooth out consumption peaks. They expand distributed generation zones. Introduce more renewable energy resources and eliminate the need to strictly synchronize generation and consumption. However, Something is going on with my slides. They keep moving. I do not do anything and they move. Thank you. Let's continue. However, it is very important to assess all the options of using ESS, the ways they will develop and how to successfully operate them. Priority ESS technologies by 2040, within this time period, where Russia should rely on is in five groups: post-lithium, electrochemical technologies, sodium-ion, potassium-ion, magnesium-ion batteries, flow-through batteries, redox vanadium, zinc, bromide, zinc iron, and a number of others, metal air batteries such as air zinc and aluminum air batteries, which are known for the low production costs and high density of storage energy, hydrogen technology based on the combination of generating energy from gas and fuel cells, gravity accumulators, solid-state accumulating electric power stations. They are based on the principle of solid cargo lifting. These type of storage, due to high efficiency coefficient, is considered as a potential technological leader of the domestic market of ESS. Currently, there are 15 enterprises that produce storage devices. Their customers are most from the defense industry, and therefore mostly they produce not ready-made ESS, but components. The largest objects in Russia where ESS are operated are hydroelectric pumped storage power plant, each EPSP, Zagorskaya, Kubanskaya, Zelenchukskaya, with the capacities shown on the screen. There are also projects to implement Kosh-Agache solar power plant with the capacity of 584 kilowatt per hour and upper and lower Borisyak plants. Foreign companies, they experience. American Tesla connected one of the largest lithium-ion batteries, 150 megawatt Horsdale wind farm in the state of South Australia. Because the Australian generation is mostly increasingly based on renewable energy like wind and solar. Then NGK Insulators, Japanese company, installed at the United Arab Emirates capital Abu Dhabi a 15 battery system across 10 geographical locations, a total capacity of 108 megawatts, and provide the declared power for 5 to 6 hours. German company Sonnen developed an ESG. Then Korean LS Power commissioned the world's largest ESS, a 250 megawatt gateway energy storage facility based on lithium-ion batteries in San Diego, California. The Chinese Cattle company developed a 100 megawatt battery storage system for the Lunenka High-Sea demonstration project. This is a combination of different types of power plants powered by renewable energy sources. The development of ESS certainly brings some risks. The main political risks of the electrical industry market development, both in Russia and worldwide, are sanctions. They can disrupt import of technology and some strategic raw materials. Social and cultural risks. Customers' distrust of the parameters, cost, and DC capacity. There is a possibility of disruption of work conditions and lack of charging infrastructure for electric transport. Economic risks, shortage of raw materials for production of ESC, and the cost of energy storage at ESC is now more expensive than the cost of production. Depreciation of national currency, slowdown of economic growth of the country. Environmental risks. These are associated with the manufacture, operation, and disposals of batteries, pollution of the environment, flooding of land, soil erosion during construction of hydroelectric pumped storage power stations, shortage of water. Legal risks. No concept of ESC that regulate, and there is no legal framework that would provide the rules for retail electricity and capacity electricity market and certain economic models, because currently ESC classified at the same time as a generation and a consumption facility. There are no procedure to connect ESCs to power plants and grids. There is a ban to combined activities of electricity transmission and purchase. The operation of any technological equipment used for the production, conversion and transmission of electricity is accompanied by serious technological risks at every stage. For example, design flaws that can negatively impact technological process, poor quality of product manufacturing when substandard materials are used, poor quality assembly, lack of acceptance tests. It all can lead to failure in operation, or poor installation technology that will affect further operation, untimely maintenance and repair, therefore deterioration of technical parameters, rapid depletion of resources and premature aging and degradation. Lack of diagnostic methods increases the risk of equipment failure. Violation of operation rules contributes to the development of defects and impossibility of normal operation. Insufficient qualification of operating staff, because the sufficient skills, the required qualifications are needed for proper and quality operation of the product. Limited time of power output. Therefore, the use of storage facilities requires very accurate calculations of the system for the balances of energy generated, stored and released. Otherwise, the system is inefficient or even useless. So the result of risk analysis give us recommendations for successful development of ESS in Russia. First, we must document ESS's concept, the order and rules of action at the market, define the procedure for technological connection of ESSs to electric power plants and grids, to remove the ban on the purchase and sale of electricity by grid companies for storage in the ESS, and define the procedures for the ESS admission to the provision of system reliability services. Trade policy, transform custom measures, introduce or increase import duty rates, reduce or introduce zero import duties of technology and raw materials, to update the system of export duties on low-level raw materials, and use own Russia's materials for production. Technology, promote the research and development process, provide transfer of research and technologies between domestic and foreign manufacturers, provide exchange of experience and in production and operation, to improve qualification, to offer internships for personnel at the leading world plant manufacturers. Energy sector, application of ESS by grid organization and interests in the interests of grid organizations. Use of ESS to provide system services in the wholesale electric and capacity markets. Apply ESS on the customer side, pass the meter. Development of a program to remove barriers to the use of storage devices in the sector. Transportation, develop a system that will incentivize the sales of electric vehicles directly to individuals. Develop a program to convert public transport to CO2-free technologies. Development the infrastructure of charging stations for electric cars. Social field, provide methodological support to ESS owners, explain the principles of operation, promote the use of ESSs among market participants. Environment, assure the fulfillment of requirements of environmental norms and standards at all life cycles. So, at the beginning of 2022, we can clearly see a new global trend in energy development. Any generation, wind, solar, hydro, should be associated with a parallel accumulation of generated energy. Russia is at the beginning of this trend, while our foreign colleagues are actively introducing and operating energy storage systems. To be successful, Russia needs to update the regulatory and legal framework for production, storage, transmission and distribution of electricity, and to codify the concept of ESS and improve the norms and features of their use. The implementation of these measures will promote the widespread of ESS use in the industrial and domestic sectors. We expect a fundamental change in the model of electricity and capacity market, improve the quality and availability of power supply, services to consumers, they develop the production of components and raw materials, as well as strengthening Russia's position in the world market of energy storage. Thank you for your attention.
So first of all, Zoom chat and then the audience. Alexander?
Here comes the question. Evgeny Batishev raises a question. How do you think that ESS will reduce CO2 emissions? Because to accumulate energy, will you generate it at the same plant that would have been generate the energy without using ESS? Well, the concept is as such. ESS is used coupled with renewable energy sources, and it will allow to step away from hydrocarbon fuels in the future.
Thank you. The next question from the audience, please.
Good afternoon. My question will be in Russian. You folks focus mostly at storage batteries, and you want to regulate the production, etc. What about recycling? For example, my mobile will lose its battery capacity in 2 years. How shall I recycle my phone battery? The answer. Currently, the recycle technology is in disassembling the elements from the battery, and some of metal is released, but it's a low quality and cannot be reintroduced into the production. Recycle is laborious and quite complicated. Currently, there is only one world company, I forgot its name, which deals with the entire cycle of batteries without disassembling them, and the released metals are of rather good quality. I think their technology will develop further and will be widely spread. What about gravitation storages? They are environmentally friendly because, let's say, stones are lifted. Why don't you focus on that? It is, being developed in America. For example, in mountainous areas, water first raised up, then pumped, and then discharged. Why there is no attention to that? Well, that technology has not yet developed. Well, that's why we focus on it. It is a promising area, but as you see, Russia is not strong in the application of storage battery technologies, and before we move to higher level technologies, we must master these technologies first.
Now we have another question from the Zoom chat. Alexander?
Indeed. I will first say the question in English, and then I will translate the question into Russian. Here is the question.
Okay, why is invest in ESS necessary when the cost is still higher than production cost? Is a recycling system being developed for the batteries when they deteriorate? Вопрос следующий.
Why shall we invest into ESS? Because the cost is higher than the production cost, and whether the recycling system for batteries will be developed when they become obsolete. Indeed, I will start answering the question with the second half of it. Of course, the recycling system will be developed. I didn't get the first question. Can you rephrase it? Why should we invest into ESS? Because their cost is higher than the production cost. Do you mean the manufacturing cost? Most likely the asker meant that. The production cost can be higher than the self-cost. But imagine the saving offered by the electricity energy storage system. If it is used at the power plant, it smoothes out the peaks in consumption, in energy output, in power output. That's exactly the answer, because you get your benefit at operating ESS. You may lose at producing it, but gain at operating
Thank you very much
it.
for your answers. It was very interesting. Thank you.
Thank you, Mr. Rossikhin. And we are ready to invite our next speaker, who is Yuri Bulatov, Assistant Professor, PhD in Technical Sciences and Head of the Department of Energy at Bratsk State University. Professor Bulatov, you are very welcome. We are ready to listen to you.
Good afternoon, esteemed audience, conference participants. Here is my presentation, Cyber-Physical Approach to Rail Power Supply System Management. I will start with the introduction, then explain the CPSS modeling methods at railroads, provide examples of such modeling, and with conclusions. So contemporary power systems of alternate current at railroads are quite complicated systems. They include two closely interrelated segments. The physical one, it consists of power elements, and the second segment, information and control components. Currently, the complexity of information and control segment is becoming comparable to the physical, technological part of the power supply system because we're living in the digital age. Therefore, it can be put into the class of cyber-physical power supply system, CPSS. And this concept is based on the deep integration of computing resources into physical processes. Here we have the aggregated structure. Monitoring of physical processes is done through feedback, extensive feedback. At the same time, the results of the algorithms affect the physical components. For example, on distributed generation units, there is an impact, and information about operation modes of power supply and current parameters of its individual models can be used to modify control algorithms and to reconfigure automatic controller, including distributed generation units. When cyber-physical power systems are constructed, it is supposed that we will use most modern information computer technologies like artificial intelligence, big data, Internet of Things. However, digital models based on algorithms for solving traditional electrical engineering problems should form the core of the virtual part of the CPSS. The aim of this research was to develop digital models and to create a cyber-physical power supply system for railroads. And to achieve this aim, the methods of modeling were developed at Irkutsk State University of Rail Transport. Methods of CPSS modeling are based on the idea that building models of elements of electric power systems, EPS, and railroads power supply on the base of phase coordinates in the main power elements of EPS and RPS are represented as the lattice substitution of schemes with fully coupled topology. The basis approach, methods, and computer technologies are implemented. The distinctive features are multi-phase, multi-mode, and multitasking. The structural diagram explaining the nature of relationships between the tasks solved in the multifunctional model are showed in the figure, and this diagram reflects the relationships of the solved research challenges and technical tasks. The Power supply system of railroad is a complex dynamic object which can be described by a system of non-linear differential equations of larger dimensionality. Here are the explanation. So we have x and a dimensional vector of mode parameters, then v, it's a m-dimensional vector of disturbing influences. C is a q-dimensional vector with which is composed by the structural parameters of power system, and C is an L-dimensional vector of controls. The model corresponds to the structural scheme as it is presented. It's larger, dimensional, and complex. Therefore, it's complicated to use the mathematical model at the present stage. The simulation methods are used to determine the model of RRPS, and to conduct simulation, the studied interval is divided into small time intervals, and each interval, the system parameters are assumed constant. And creating a simulation model of RRPS requires to have building models of individual elements and determining the algorithm of their interaction. And it includes the components like simulating the train schedule, create circuits which corresponded to each time interval and calculation of mode for each of them, and determining the integral indicators of simulating modeling. At all time intervals, the following nonlinear system of equations is solved, and it describes the steady-state mode of the corresponding instantaneous diagram. The vector values are given on this slide, and the proposed modeling methodology was done through the Fuzz Nord software that was developed at Irkutsk State University of Transportation, and it allows to calculate models of electric power transmission system with three complex subsystems: power supply system for traction, external power supply system, and power supply areas of non-traction and non-transport consumers. Here are the key segments of electrical core of the CPSS. The state estimation based on information received through CPPS information network channels, then forecasting of loads, formation of simplified equivalent model of external EPS, the modeling of train schedules, traction calculations, and other things. The specifics of the cyber-physical approach is that the digital model described above is continuously updated based on the processing measurements by the information coming from PMU WMS devices synchronized with the signal from global positioning satellites. Satellite technologies are used to generate train schedules, which is relevant especially for high-speed rail lines. When we generate CPSS, the concept of the energy internet can be used. And there, the traction substation and the network adjacent to it can be considered as an energy cell, as shown at figure 6 on the slide. The composition of the cells, in addition to standard equipment of transformers and transformer substation, may include the following active elements of smart grid: active harmonic conditioner, ACG, again, energy storage, longitudinal compensation units, distributed generation units, etc. To control energy cell and its active elements, the multi-agent technology can be used. Let us now consider an example of application of the model as it was described for CPSS. The diagram is on the slide. We simulated the movement of 9 trains with a mass of 4,884 tons in the odd direction. The current train profiles are presented on this slide. It was assumed that a regulated RPS was installed on the 220 kilovolt buses of transformer substation, providing stabilization of the line voltage at 216 kilovolt. The simulation results are presented on this slide. The negative values of active power at figure 9b show the regenerative braking modes with return of electricity energy to the network. The simulation results allow us to say the following. On the simulation interval, we see a voltage drop on the current collector of train 9. That's figure 9. And it requires to correct the mode by including the regulated reactive power supply on the buses of 27.5 kilowatt of the traction substation. We also see the asymmetry coefficients of the 220 kilowatt buses of traction substation 2 and 4. They exceed the normally permissible limits, and if the time of excess exceeds the value of 5%, it is necessary to include symmetry devices, and harmonic coefficients on 220 kilovolt traction substation bus bars also out of the allowable limits, and it requires the inclusion of active harmonic conditioners. Now the conclusion. We offered the methods to determine the modes for cyber physical power supply system for AC railways, and the computer modeling resulted and showed that effective computer models can be implemented to solve these problems using the methods for model of EPS and RRPS in phase coordinates. Thank you.
Thank you very much, Professor Bulatov. And now, do we have any questions from the audience or from the Zoom chat? I think that everyone is a little bit shocked with your very particular information, and we will gather then questions and send you it by email. So now we have a next presentation.
Yes, we're ready to invite our last speaker. We're going to thank you very much, Professor. Very, very informative. We're welcoming Andrey Svetkin, Deputy Head of the Department of Oil Extraction at Zarubezhneft Joint Stock Company. Mr. Svetkin, the floor is yours.
Добрый день, уважаемые участники конференции.
Good afternoon, esteemed conference delegates. I wanted to make a confession before I make my presentation. 15 years ago, more than 15 years ago, I made a step that I regret. I never shared this information, but I think it's the right time to confess. In 2004, when I was just a young school leaver, I selected a university to enroll into, whether electrotechnical or oil university. I decided on the oil university. Today, most of oil and gas companies want to become energy companies. They change even their name. They drop oil and gas from their title. Зарубеж нефти, translated as foreign oil, keeps the word oil in its title, but we are active in developing new technologies, and results of 2020 put our company into the top of oil and gas companies when it comes to environmental responsibilities. Let us, however, focus on the theme of my presentation. We have a field, an oil field, 100 kilometers off the Arctic Ocean coast, and you can reach this location at summertime only by helicopter. And we have some power challenges. Of course, you cannot connect the equipment to the grid, and therefore we have a fuel gas which turns the gas turbine. However, there is a high content of hydrogen sulfide in the APG, associated petroleum gas, and we use the membrane technology to treat and to purify the gas. But there is a high percentage of permeate in membrane units that we use. That's why we thought of how to make the use of this percentage. Currently, we use diesel station, but it's expensive and it's not environmentally friendly. So we searched for solutions. Initially, we thought of using min desulfurization plus closed process, but that was unrealistic. It's too expensive, and that's the utopia. But how can we clean the permeate of hydrogen sulfide? Therefore, we made a market analysis, and there were no ready-made solutions. At that time, we contacted Moscow State University, named after Lomonosov, with the task of purifying the gas, preferably at one stage, preferably at temperatures 25 to 30 degrees without heating. In 2018, the university, together with Stat Catalyzer company, they developed the nanocatalyst unit for us. First, we tested it in the lab. Over 10 experiments that showed that indeed the catalyzer proved to clean the APG and removes mercaptans as well. Then we brought the catalyzer into the field, and again it proved useful. Then through year 2019-2020 we developed the design documents and produced the pilot unit, which completely purifies the gas. And we tested the unit at 2 fields in 2020, and as I'm talking to you, the unit is being tested at the industrial scale of the APG. That's the principle of operation. As you see, the diagram includes 2 adsorbers, number 1 and number 2. The first adsorber is filled in with reaction mixture, and APG full of hydrogen sulfide moves through adsorber 1 through the catalyst layer and goes to the turbine, and it operates from 3 to 5 days, and then it switches, the process switches to adsorber 2. And adsorber 1 releases the drainage mixture, which is then separated into the catalyst liquid and sulfur. Here is the sulfur sample that we extracted from our APG, and lab confirmed that that's a ready-made product. It's commercial good that can be sold. Here is the assessment of economic efficiency. It is proved that at a rather small initial investment, you can get the NPV after 14 years above 1 billion rubles. The project is sensitive to cost of diesel fuel and permit gas volume. Whatever name your company has, whether it includes oil or gas into its title, the activity of the company means a lot. And if you are focused on energy efficiently, our world becomes quieter, cleaner, and environmentally friendlier. Green, some years ago, meant young and inexperienced, but now green means active, innovative, and forward-looking. I'm done. Do you have any questions?
You wasn't a student of Latif, but we are very glad that now you are our colleague. We work together. Thank you so much once again. Do we have any questions in the audience, in the Zoom chat? Okay, if there will be some questions, we will prepare a letter for you and we'll send it by email. Thank you so much.
Thank you for your attention.
So, dear participants, today's session has flown by. The conference has started, and the most interesting speeches of the speakers of the four main blocks await us.
And today we're going to meet with reports on the two topics: energy efficient solution and engineering systems and digital transformation for energy companies.
Tomorrow we are going to be acquainted with the reports on the topics of economics and new energy markets in the transition period and personnel of the industry.
So, dear participants, we thank you for submitting your reports and participating in our discussion. We will continue it.
We aren't saying goodbye. Obviously, we remind you that ahead of us is the session Energy Efficient Solutions and Engineering Systems. And now we invite all of you to participate in the lunch break. Thank you very much.
And we will meet you in 14 o'clock, 2 p.m. here in the same place. So see you after the lunch break. Thank you once again.
Thank you. Guest from São Paulo University in Brazil, Dr. Marcelo Augusto Leal Alves. He is a journal reviewer at Vehicle System Dynamics and works in the field of mechanical engineering. Throughout the years, he participated in dozens of events and authored a number of scientific publications. Dr. Alves, you are welcome.
Well, thank you very much for your introduction. Well, first I should say Dobry dien to my colleagues in Russia and abroad. And well, I'm going to share my presentation. Okay, so we are talking about today about the energy perspectives for the automotive sector in Brazil. That's the area I work with. First, a little bit about São Paulo and our university. If you don't know, São Paulo is the largest city in Brazil, and the University of São Paulo is not the biggest in numbers, but the most important university in Brazil. I invite you to visit our website, and if you are here in Brazil somehow, please pay us a visit. Okay. Well, Brazil has a relatively large market for vehicles. We are the 60th largest in 2019. So after COVID, the numbers have changed a lot because everybody knows why. The situation, the economic situation globally was very much affected. Well, but we have a closed economy. So our market is basically isolated from the global production chains. Brazil is not a large exporter of vehicles. This is make us very different from Mexico, for instance. Mexico lives close to the USA, so mostly of the Mexican car industry is attached to the American and Canadian car markets. That's not the case in Brazil. We have a closer link to Argentina and Uruguay, but mostly the production is devoted to the local market in Brazil. So, but on the other hand, the key players in the market are not Brazilian. So they are foreign companies. The decision centers are out of Brazil. And this makes things a little bit complicated because they have to follow the global trends that may not be aligned to the national priorities. For instance, we have a local solution in terms of energy that is ethanol, a biofuel, but it's now in competition with what is a global solution that is electrification. So what we are trying to see today, how is we can equate or somehow balance the local interest with the global solutions and the global interests. A little bit about the situation in Brazil in terms of fleet. This is for passenger vehicles, for cars. As you can see, from 2005 onwards, most vehicles, they are flex fuel, that is an engine that can run with any mixture of gasoline or ethanol. We have the option to choose what kind of fuel you can put on our cars here. And this is based mostly by the price at the gas station. So the driver can choose based on price and an efficiency which fuel it will be running the car. Electric and hybrid it's a very small participation on our market, mostly because they are only imported. We do not have local production in significant numbers for electric and hybrid vehicles. And if you are curious, diesel passenger vehicles for automobiles, they are not allowed by local regulation. We do not have diesel cars, even for taxi or fleets. Diesel is only used for cargo transportation in Brazil. In terms of numbers, the newest vehicles, they amount to the majority. We are talking about more than 40 million cars in Brazil.
Professor, I'm terribly sorry, but you might not have shown us our screen because we are still seeing the first slide of your presentation.
Oh,
perhaps
okay.
You should change the view.
Just a second. What about now?
Fleet situation in full screen. Apparently, that's...
Yes, perfect. It's a demonstration mode. Yes, very fine.
Thank you.
Okay, sorry about that.
No, it's okay.
I was talking about the fleet situation. As you can see, most vehicles run on flex fuel, as I said. Diesel is not important for passenger vehicles and because of local regulation. And hybrid and electric, it's again irrelevant because they're all imported. In terms of energy, electricity generation, most of the energy comes from hydropower. That is 64% of the energy, electricity in Brazil is generated from hydroelectricity. Oil and gas is about 27%, wind 7%, nuclear 1%, and solar 0.1%. Other forms like biomass, waste is 0.5%. So as you can see, we do have a very stable, environmentally friendly electricity generation. But on the other hand, we do not have a surplus. And quite the opposite. We are facing now an increase on oil and gas because of the heavy usage of our hydroelectricity sources. So electrification of the fleet here in Brazil would pose a difficulty because there would be a need for investments, for new power plants, new distribution lines, and that would mean at first a little bit more of thermal, and it does mean oil and gas. If you go a little bit further on CO2 emissions, we would have a comparison of Brazil with other countries and other regions. Brazil, in terms of emissions, it's not the leader. Most of it the emissions comes from the deforestation, and transportation. It's not relevant as in the USA or in Western Europe, and the generation of energy, mostly electricity, also it's not much relevant in terms of emissions if you compare to other regions of the world. So electrification, on the other hand, in Brazil would not be very problematic in terms of increase of emissions. But anyway, we would have a problem in making investment towards new electricity sources. I'd like to explain a little bit about ethanol as a biofuel. Ethanol is used as a replacement to gasoline. The research started in the 1930s, mostly in the UK, France, and also in Brazil. UK and France because they had colonies in tropical regions where sugarcane production was feasible. And the main oil reserves in the 1930s were mostly in the USA and Mexico and Central Asia. And the discoveries in Central Asia and in Arabia, it halted the research because all of a sudden oil became very cheap. On the other hand, in Brazil in 1974, we used mostly foreign oil as source for fuel. And as you may know, in the early 70s, we had the oil crisis. And all of a sudden, gasoline and diesel became very expensive. So what this country did, what Brazil did, we invested in ethanol as a replacement to gasoline. And we started to look for oil, especially in our coast. Now Brazil is self-sufficient in terms of oil. We have a lot of oil production in offshore, but we do have ethanol as a biofuel. It created an industry of fuel based on sugarcane. And the country also had a large plantation of sugarcane. It's a very relevant economic activity in Brazil, and is a national source of energy. We are not dependent on foreign based energy sources. So strategically, it was an interesting option. By 1985, we had almost 100% of our fleet running on ethanol. We had developed products that would resist corrosion, that would start in cold weather. I mean, cold in Brazil is not the same, of course, cold as in Russia, but ethanol is much less volatile than gasoline. So starting a colder day in the southern of Brazil would be a little bit more complicated. It has some disadvantages in comparing to gasoline because it has less energy in the molecule. But as I said, it's what we use as a source, local source of energy for cars. In the early 90s, we had a crisis in supply of ethanol. It generated a confidence crisis, so consumers decided not to use ethanol anymore because the supply became unreliable. The reason is the government changed the policy, and it became clear to the productive sector that it would be better to sell sugar in the international market than to sell ethanol in the Brazilian market. The reason was linked to the Brazilian currency being very weak. And if you sell sugar abroad, you have an income in stable foreign currency. Well, this thing was sorted out in 2003 when this flex fuel engine was launched. It runs in a mix of gasoline and ethanol. So you can choose what fuel you can put in your car. The fuel injection adjusts based on the emissions data. So you have a mapping on the central computer in the engine. So the engine adjusts itself to the right mixture. Again, it was a local solution. There is, of course, a question what we're going to use, what we're going to do of the land use. Are we going to produce food of energy? This conflict is not really real here. We have abundant land for agriculture. And nowadays, what we are seeing is the possibility of use ethanol as a fuel for a fuel cell. You may all know that hydrogen is being experimented as a source of energy for the vehicles. The problem is how we transport hydrogen. To create a distribution network of hydrogen is very expensive and will demand a lot of investment. So what we are researching right now is the use of ethanol in a fuel cell. And in this way, we can already use the production of ethanol that is already in place, the distribution of ethanol that is already in place, together with this very new technology that is the fuel cell that can power electric vehicles. So this is the far front of the research locally in Brazil, is to put ethanol as a fuel for fuel cells. We have some connections to some car companies. You can even find news about this. So if you do a Google ethanol fuel cell, you can see that it's a large car manufacturer that is already doing research. Locally, we're doing a lot of research on this field.
Hate to interrupt you, Professor. Very, very sorry. Please stick to the timing.
Okay, I'm going to stick to the time.
Thank you so much.
Okay, electrification would be a little bit complicated in Brazil because of the demand for new distribution and generation. If you compare the emissions, ethanol, it's a little bit better. It's much better than gasoline. And is competitive with electric vehicles, especially depending on your source of electricity. If you burn coal, certainly it's much better to have an ethanol car in terms of global emission for the source to the wheel. So I call your attention to that data because this is very important to remark. Okay, I'm going to the conclusions. The size of local market cannot sustain the investments on electrification. I mean, we cannot finance the development of a new industry here locally. So you have to integrate the local industry to the global chain of production. We have to become an exporter of vehicles and parts. This will be complicated because this will lead to more competition to the local industries. And we do not know if the local industry is capable to face the international competition, especially from China in terms of costs. That is going to be very complicated to the local industry. We have this local solution that may not be practical to other countries, but is very important to Brazil. So we want to maintain it because we have an industry around it. And of course, you have the societal costs of overhauling the whole auto industry. Basing this overhaul on environmentally reasons is not only that simple here in Brazil. We have other environmental problems that are not related to the automobile. And the decision-making process is external to the country. And we do not want this happening. What we want to keep some decision making here in Brazil, because the industrial sector and the automotive sector, they are both very important to the economy of the country. So if you want to have some decision making in Brazil, we need to cooperate with the industry and want to understand how the decisions are being made abroad, and want to at least to move the needle towards of our own national interests. So thank you very much for your attention. I'm going to say sorry about the complication at the beginning of the presentation, and well, thank you very much again for your attention.
Dr. Alves, thank you very much for your great opening talk. And now for our audience, you are welcome with your questions. Yes, please. Yeah, the microphone is coming.
St. Petersburg Polytechnical University, Arlenikova, the High School of Energy Sector, Associate Professor. Professor Alves. My question, do you continue the project that was started at our university about biofuel, bagassa, and use of sugarcane? And Professor Rector Silva Laura was one of the initiators of that project at Ashuba University. Do you continue working in the same field about bagassa burning, bagassa biofuel burning?
Okay, the question is, are there any work at the present moment that been started long ago at Peter the Great University connected with a biofuel at your country? Bagassa, yeah, the name is Bagassa, the project name.
Well, I really couldn't hear quite well the question, but as I said before, we are using biofuels for a very long time. So other countries try it. I really do not know the situation about biofuels now in Russia. There's a lot of talk about biodiesel. That is another kind of biofuel based on soybeans and whatever. But this is minor, I would say, in comparison to ethanol. Again, we understand that this solution is quite difficult to replicate abroad, mostly because in other countries there is the competition for land between what we're going to use the land. Is it for producing food or to produce energy? And we do understand that to many countries this is a problem. On the other hand, in our context, this is not problematic at all. We still have a lot of space to increase the productivity of the sugarcane as a plant. There is also a lot of research to make genetically modified sugarcane plants to make it more productive using the same amount of land. So this is the research that was developed in the last 20 years in the School of Agriculture. So this is something that we are doing in parallel. But as I said, I mean, I think
yes,
it's quite difficult to replicate abroad.
Yes, sure. Thank you for your answer, and thank you for your participation once again.
Thank you very much. I see.
We have question from Zoom.
I guess we can collect the questions and send it to Professor Alves.
Okay.
A little bit out of time.
Thank you very much. Thank you, Professor. We're ready to.
Thank you very much. Спасибо and muito obrigado.
Thank you. And we're ready to invite our next speaker, Ekaterina Trusova from St. Petersburg Electrotechnical University. She's a graduate of the Faculty of Industrial Automation and Electrical Engineering. Of 2021, she has authored 3 scientific papers in IEEE Proceedings Journal. Welcome, Ms. Trusova.
Good afternoon, dear colleagues. Today I'm going to tell you about modeling an energy-efficient, uninterruptible power supply based on a modular multi-level design. Nowadays, there is a trend towards more energy-efficient converters of electricity. Most of converters are based on managed keys, as earlier they were based on unmanaged keys. And this solution allows for double-way energy exchange, power factor control, and the acceptable harmonic composition of the current drawn from network. For a long time, various converters have been presented on the market, which perform their work at a sufficient level in conjunctions with transformer and the filter. And today the cost of transistors is decreasing and the prices of active materials of transformers are increasing. And that's why a fundamentally new direction of development of converters is being formed. This direction consists of the design of energy efficient transformless multi-level converters based on modular structure. And in the slide you can see some advantages of modular multi-level converters, and they are absence of a transformer and absence of a filter. Also possibility of redundancy. The modular design can be easily adapted to different levels of main voltages by changing the number of submodels connected in series. And also the advantages are high quality of output voltage of the converter and high efficiency and energy efficiency. And also they have some disadvantages, and the disadvantages are large mass and dimensions of modular multi-level converters and complexity of development. Figure 1 shows a diagram of a modular multi-level converter. The converter includes 2 arms. The converter includes 2 branches, phase A and phase B. Each branch includes 2 arms, and each arm consists of n series connected identical cells and the current limiting inductance, as well as an active resistance, which represents switching losses in semiconductors. In figure 2, you can see a bridge cell, which is used as a module in converter. During the operation of the converter, some of the cells are on and others are off. Switching on the submodel in one arm of the branch is accompanied by synchronous disconnecting the cell in the other branch. To determine the number of models included, insertion index of each model is introduced, and if this index is equal to 1, the cell is on, and if this index is equal to 0, that's the cell is off. And figure 3 shows an equivalent circuit of modular multi-level converter. All modules in the arm are represented as a capacitor voltage divided by number of working modules. In figure 4, you can see the algorithm for regulating the arm tension. The task of this algorithm is to select the best configuration of arm cells to maintain the necessary voltage between the arm capacitors. As mentioned earlier, depending on the direction of the current flowing through the cell, the voltage of the capacitors changes. It can increase, decrease, or remain unchanged. Without proper regulation of this voltage, some structural cells will require more than others. and that can lead to charging some cells and discharging the others. In each cycle of algorithm, the voltage of cells in one arm is measured. Then they are sorted in descending order of voltage. And if the current of the arm is if the current of the arm has positive direction or it is equal to 0, the cells with the lowest voltage, switch on, and otherwise the cells with the highest voltage switch on. In figure 5, you can see a model of converter arm. Our converter has 4 these arms, and
1 minute, please.
And each arm has 3 bridge cells. These are the results of modulation. In figure 6, you can see the circulating currents, and in figure 7, you can see the instantaneous values of phase current of the controller. Total losses of the controller are obtained from switching losses and conduction losses. Efficiency is determined by a well-known formula, and it should be kept in mind that the loss power of converter consists of the losses of each cell separately. And the efficiency of uninterruptible power supplies based on a modular multi-level structure will be about 98%, which indicates the high energy efficiency. Conclusion. Advantages of modular multi-level converters significantly reduce the cost of production of equipment and repair work and increase the energy efficiency of the controller. UPAs based on modular multi-level converters will allow to achieve a high efficiency value by increasing the number of semiconductor elements and accordingly high energy efficiency. And also the efficiency of uninterruptible power supply of a modular structure is significantly higher than of a classic one, which significantly improves energy efficiency and reduces energy waste. Thank you for your attention.
Thank you for your talk. And dear audience, you're welcome for questions. Yes, I see the question here.
Good afternoon. Here is my question. You reviewed the multi-level converters, so you may connect them in series. In your model, you reviewed that each model will require a separate power source. Did you agree? Yes. So what was your logic approach? So what about balancing the chain of direct current in these converters? And at what level have you solved it? At the active rectifier, when we put into the chains of direct current, or at the bus bar level, at the bus level? So you use the sinusoidal bus, as I see. The question is about efficiency. The more level there are, the better is the voltage quality. That's clear. But in terms of we need the multi-level and the balancing of the direct current chain. And how many levels we have? 12 levels, 7 levels. What about dimensions? Can you speak in Russian?
Yes.
What about dimensions? I mentioned them in the beginning. The more power we need, the bigger are the dimensions. So there is no transformer in there. We just have the serious connection of bridges. And when it comes to regulation, the arm voltage, here is the algorithm which checks in each cycle the voltage in these condensers and either recharges them or keeps them at the same level, more or less. Your algorithm, does it provide for this situation? Let's say, I think that's a perfect conversation for the coffee break, but let me just ask it from the audience. Whether your algorithm provides for the short circuit if one chain drops out. The algorithm does not provide for the short circuit, the specific one. But if we improve the algorithm, then the short-circuited chain will be just bypassed and the device will continue operating.
I guess other questions could be addressed during the coffee break to be on time. Okay, thank you. Your presentation raises many questions. Thank you again.
Thank you very much, Ms. Trusova. We are ready to invite our next guest, Irina Lazareva from Peter the Great Polytechnic University, a formidable educational institution from St. Petersburg that keeps getting more and more prominent with every year. Ms. Lazareva, you're welcome. Please try to stick to the timing. 7 minutes max.
Good afternoon, conference participants. My presentation is justification of reliability of VVER 1200 pressurized water type reactor with mixing grid installed in the fuel assembly. The important problem of the nuclear power is to ensure the operational safety of existing and designed power plants. We need to properly organize and sufficiently accurate calculate the conditions of heat exchange to set up a well-working nuclear reactor. The modern power engineering has one of important tasks to improve the efficiency of such reactors. We need to do research at many fields to increase the installed capacity of operating power units, by improving equipment, increase the installed capacity utilization factor, ICUF, and to increase the burn-up of nuclear fuel, among other things. My objective is to justify the thermal technical reliability of VVER 1200 reactor by the design of advanced fuel assemblies with vortex and run type mixing grids installed to increase the critical power of the assemblies and affecting the increase in power generation at the reactor. So the goal is set. The following tasks were performed, one after the other. First, thermal hydraulic calculation of the reactor active core in VVER 1200, the coefficient of reserve prior to the heat exchange crisis, and I had conclusions. So I considered the thermal hydraulic processes in active core for the heat exchange crisis of the first time. The practical importance of my job is to determine indicators of core thermal and technical reliability responsible for the safety of the reactor. So the purpose is there, and we need to justify the reliability of fuel assembly with mixing grids. So the methodology is to identify the point of surface boiling onset graphically. The steam water flow parameters in the surface boiling zone were found with the method of Mirapolsky and Asmachkin. Calculation of pressure losses was performed without boiling and taking into account surface boiling. boiling. Hydraulic losses of steam water flow in the surface area were determined by a Lacarte-Martinelli method. So the Yuri Bezrukov methodology was used to calculate the critical heat flux density and reserve coefficients to the heat exchange crisis. The approach allows to provide a complete assessment of thermal reliability of the reactor unit under the identified criteria. The evolution of VVER technology is due to the upgrading of fuel assemblies. The new fuel assembly has minimized the possibility of depressurization and the design of repairable and allow the use of new types of fuel, MOX and remix. The fuel assembly TVS-2M is in the slide. It's the new generation, and it has the cassettes with the enlarged fuel column. The fuel cycle becomes longer, 18 months, and reactor can operate at the increased capacity of 104%. The specifics of TVS-2M is in the design of welding of the guide channels and spacer grids. The rigid framework is created and it is unaffected by irregularity of neutron and temperature fields. So VVER is a non-boiling reactor. However, the most heat-stressed fuel assemblies in the center of the active core can be subjected to surface boiling. The boiling occurs in the narrow near-wall layer, heated to the saturation temperature, while the main part of the coolant has not reached the saturation temperature. The mass or vapor content is strictly regulated, and for VVER 1200 reactor shall not exceed 11.4% at the fuel assembly at the outlet, at the maximum energy release. We need to increase the pre-crisis reserve, and in addition to distancing grids, we offer 4 mixing grids. The mixing grids are of run type to transverse transfer of mass to the main flow. Vortex types allow to create a vortex, and they are put in the first 2 spans prior to the boiling surface. And that's how the temperature is equalized. Removing steam bulbs, we need vortex type mixing grids. The flow passes through them and is swirled, and the centrifugal force directs the water to the periphery of the vortex, and the steam is collected in the center. This is how vapor content is reduced in the flow, and the heat exchange crisis is delayed. The main indicator of reliable operation of fuel assembly is the reserve before the heat exchange crisis. So the ratio of the critical heat flux density to the value of the maximum heat flux alone is between 1.2 to 1.3. That's the safety factor for VVER 1200. So we justified the reliability with 4 vortex and run-through mixing grids. So we coordinated the beginning of surface boiling and find the main parameters of the steam water flow. The mass steam content at the fuel assembly outlet was 7.4%. This is less than 11.4%. That's the regulated safety criteria. The reserve pre-crisis thanks to the adding mixing grids, increased by 5%. The review of results showed that adding 4 grids in fuel assembly increases the thermal reliability of the core and allows it to operate the unit as industrial operation mode at an increased power level and leads to the increased energy efficiency of a nuclear power plant. Outlooks for the research. We would like to say that we need to continue studying the methods to determine losses of the area of surface boiling in the assembly fuel using the numerical model software and ANSYS.
Thank you for your talk and your presentation. It was very interesting indeed. So, dear audience, do you have any questions? Okay, do we have questions in chat? Okay, then I can ask you.
Yes, we have.
Okay, you're welcome.
Give me a minute. Here is the question. What is the material of mixing grids? Well, those mixing grids vortex and run through. Well, this is just at the design stage, and to give you exactly the material to manufacture these grids, I'm not ready yet. It's a small improvement step, so I'm not ready to answer your question.
Okay, thank you for your answer and your presentation. We are ready to invite the next speaker.
Thank you very much. We have a very quick speech from Yelena Stepanova from Kazan State Power Engineering University. Please, Ms. Stepanova, you're welcome. She's in the Zoom.
Hello. I'm uploading my presentation. Can you hear me? Can you see me? Yes, everything is perfect. But can we have the full screen mode? It should have been the full mode. Can you see it? No. We don't have it. So we repeat the same story as previously. Do you have the second screen? No? Only one screen? And your presentation is in Russian? Indeed, but the qualifying requirement was to have an English presentation. What shall we do then?
Okay, I guess we have to welcome our next guest then, because the presentation has to be in English in order to be qualified for the conference, I think. So next speaker is going to be Artyom Kochergin, a graduate student from Faculty of Electronics here at Leti. He's about to give a presentation about testing of solar panels. Mr. Kochergin, you're welcome.
У меня тоже презентация на русском языке.
We're going to have to pass on the opportunity to listen to you, Mr. Kochergin. I'm terribly sorry, but the presentation has to be in English, as was previously. Все очень, да, очень легитимно.
Okay, Mr. Kochergin, we are giving you the floor. I will find some clarifications with regard to this challenge. Can you see my presentation? Yes, again, it is not in the full screen mode, and it cannot be switched. Please, when you demonstrate PowerPoint, please click full screen mode. So push this button. Do you have two displays? No. You cannot see it in full screen. At the bottom right corner, next to the plus minus, there is an icon. Try to click it. Can you make your presentation bigger then? Okay, I will. Please, when you share your screen, select show the screen, not show the presentation. Yeah, now everything is perfect and you can start. Good afternoon, organizers of the conference and participants. I'm Kochergin Artyom. I'm a PhD student at St. Petersburg State Electrotechnical University. My work is climatic and mechanic tests of solar panels, of heterostructure photoelectric converters with the copper grid. Here is the key elements of making solar panels, and you can divide them in two key stages. First, creating the photovoltaic converter or photoelectric converter PEC, it's in the center, and then assembling these converters into the solar panel. We start with chemical treatment and depositing, and then the contact grid is created, and that's exactly what I'm going to discuss. About 90% of all solar modules today have a contact grid, and they do it through screen printing with silver paste, and the increased production of solar panels may result in the shortages of silver and its higher prices, and it can endanger the further development of land solar power. The alternative to silver is copper, and it is widely used at electronics and electroengineering. It is cheaper, and there are more reserves of copper on the Earth. There are two price tags using silver and copper for grid, and 1.5 cheaper is the grid with them copper than silver. So we also considered the impact of insolation and climate on two types of solars. We wanted to measure key parameters and resistance of PEC with the copper grids, and we wanted to do climate tests. So we used heterostructure photoelectric converters with silicon conductivity. The slide shows the process we developed to create a copper grid. First, neutron sedimentation or depositing, then the protecting mask using jet printing is done, then electrochemical depositing of copper, and the last stage is removing the protective mask and sub-buffers. So then we tested the parameters of PECs with copper grid. This is the luminescent photo So it was possible to do the adhesion without damaging the boards. The efficiency coefficient for PEC with copper grid is 21.5 to 22.2, which is good for initial testing as the rate. So the bus bar length was 1 millimeter for current conductivity, and for the runs is about 55 micrometers, which is similar to silver grid. We then plan to decrease the width further. Then we decided to test for damage, and we created two modules with silver and copper grids. These are photography in photoluminescence after the damage, and it is visible that in fact the copper grid acts as the holder, as the holding net, holding together pieces and providing conductivity for currency. We considered the degradation of maximum power, so the degrading for copper was 13% and 24% for silver paste. Another important parameter for solar modules is their durability. The international committees put up the testing methods, and they are part of the international standards. So we set up two solar modules with converters of copper grid, and we put them into a thermal chamber. Thermal cycling, first type of testing. So the temperature cycle was between -40 to +85 with the total number of 200 cycles. And the pass criteria is that the maximum power is degraded no higher than 5%. So we did 225 cycles, and the degrading is only 0.7%, which shows that the copper grid has passed the test successfully. The curve shows that the main part of degrading happened during the first 125 cycles. Now, humid thermal impact. The module was tested at +85 and 85% of humidity during 1000 hours, and again, degrading of maximum power should not be higher than 5%. Results, the maximum power of our unit degraded only by 3.1%, which again testifies to the success of the test for this module. I'm done. Thank you for your attention. And my job shows that it is possible to move away from traditional silver paste screen printing to chemical deposit of copper grid. Thank you.
Thank you for your talk and your presentation. Dear audience, do you have any questions? No questions from audience. Maybe do we have any questions in chat?
No questions in the chat.
Okay, so we are going to thank you again for your presentation, and we are ready to move to our next speaker. So thank you again.
Спасибо вам. Thank you very much. Our next speaker is going to be Rustem Gaintetdinov, an engineer at Gazprom Transgaz, Ufa. Mr. Gaintetdinov, are you here? You're welcome.
Can you hear me? We can hear you perfectly well. Good afternoon. My presentation will be in Russian.
Yes, okay, you're welcome.
Okay, I'm going to share my screen. Can you see my presentation? Hello again.
We can see your presentation, the second slide, not in a full screen.
Спасибо.
Good afternoon, esteemed conference participants.
Rustem, not full screen. Could you please try to change it?
So it's not full screen mode, and you start with the second slide. Give me a minute. What about now? Is it better? This is the second slide, though. Shall I start?
You're welcome.
Thank you. As of today, in the system of Gazprom joint stock company, we have this challenge of the elastoplastic deformation of bends and strained condition of the main gas pipelines. So there is a high chances that our pipes will run through difficult terrains. The most difficult conditions for pipeline are landslides and areas with tectonic faults, because the spatial position can be changed during the land shift, and the change axes may result in higher strain and stress on pipes beyond the standard calculations. And therefore, we need to assess the operability of gas pipes, and it is identified for overhaul and during the complete opening of the pipelines. How do we survey our pipes? Through geodetic surveying methods. They can be traditional with theodolite. And we also run digital analysis and review. Today, when we inspect pipelines with unmanned aircrafts, drones, we identified a certain specific which allows us to develop methods that can identify these stressed deformed states, and we develop the methods by using high precision 3D models based on the data provided by drones. And for surveying, we used unmanned aircrafts, a helicopter type, and the flying wing type. We used Sbercom Phantom 3 with camera, and we used Javat Triumph 1 base station. The method was tested at kilometer 15 at Karman area in Bashkortostan. The length was 200 meters, 700 millimeters at the diameter, and 12 meters is the height difference. Using the drone data, we set up the 3D models for relief and for the pipeline, and the precision was 5 centimeters per 1 square meter. We analyzed the methods of different types and compared them to the traditional surveying, geodetic surveying, where theodolite was used, and the geodetic expert from our design department was involved. And we also compared the data from the amateur drone. The results were compared, and you can see 3 curves to the right. So the unmanned aircrafts with GNSS receiver were compared to the traditional surveying method. The overlap was 98%. With unmanned vehicles, we have shorter times needed for surveying, and it allows the additional control over the linear gas pipelines, so we can cover big length and identify elastoplastic deformation and stressed deformed state. So, in conclusion, the use of high-precision 3D models allows to do calculation not only for gas pipelines, but also for overhead electric lines, for large terrains. The increased precision allows to our engineers and experts to do high precision measurements through 3D modeling. Thank you.
У меня все. Спасибо за внимание.
Thank you for your talk and your presentation. Dear audience, do you have any questions to our speaker? Okay, are there any questions in chat that we have?
Yes, there is a question at our Zoom chat. The question, whether this method potentially can be a substitute to traditional geodetic surveys. Indeed, this is our prime goal. That's why we wanted to compare the use of traditional survey, geodetic survey, and unmanned aircrafts of geodetic type. And we showed the convergence of 98% of the data overlapped. So it means there is a potential. Currently, the challenge is no norm setting and technical standards and no guidelines for this type of job that would allow us to use this method of unmanned aircrafts for surveying, and of course these aircrafts of geodetic class.
Thank you for your answer. Okay, so we are going to thank you again for your presentation and ready to move to the next speaker.
Thank you, Mr. Gaintetdinov. All the best to you. We are ready to invite our next speaker, Ivan Prokofiev from Novolipetsk Steel. He's the head of Young Engineers of Fuel and Energy Complex and a recipient of a number of professional awards and an author of multiple scientific papers. Mr. Prokofiev, you are welcome. Hopefully you have a presentation in English. Please tell me so. Okay, this is a relief.
Good day, dear colleagues. My presentation is in English. I'm Ivan Prokofiev and I represent the Power Alumnica company. Argon is the most common inert gas and is the third most common chemical element of the atmosphere air, 0.93% of the volume. It's a gas with the boiling temperature of 185.9 degrees Celsius, a bit below than that of oxygen, but a bit higher than that of nitrogen. Doesn't form chemical bonds, so the production of pure argon is huge, millions of cubic meters per year. Argon is necessary for a number of new technologies. It's a protective environment for machine building at welding and cutting of light metals and special steels. In metallurgy, when producing and processing high-quality steels, non-ferrous and alkali metals. We needed an electronic, in lighting for bulbs, etc. Well, it's also used for processing of rare metals like zirconium, tungsten, niobium, and beryllium. As for the spectral analysis and metrology, argon is frequently used as inert environment and carrier gas for control devices. Well, the need for argon keeps growing, and requirements to its purity are growing as well. Depending on the application field, argon has to be of different kinds of purity levels. The updated GOST 1015779 is subdividing the argon into the supreme and first brand to satisfy the modern requirements in quality. The technologies at production and purification of argon were improved. New norms were introduced. So there are special brands of high purity. And high purity is classification 6.0. The technology of production of argon has certain drawbacks. It's difficult to purify it from oxygen. That's why it's a bit expensive. Well, the production of pure argon consists of certain stages. First, it's the selection of fraction from the rectification column and production of raw argon. Next is a purification of raw argon from oxygen, and finally purification of argon from nitrogen. The second stage is most difficult because the boiling temperature of argon and oxygen are nearly the same. The first method is the low temperature rectification. It's done to raw argon or fraction of argon in a special unit. The benefit of this method is a usage of contact devices, metal mesh that enables to do purification in columns of small diameter. And usually double rectification is used. There's the lower column of high pressure, upper column of low pressure, and the interim condenser and evaporator. The raw argon fraction is extracted from air in two stages. That's the fraction with 5-12% of argon. It's taken from the column and then it's beneficiated in a special argon column. Hence, we get 70-95% of argon. The purification of raw argon from oxygen is done using different methods. And industrial amounts of argon of a special purity is obtained, and it may be used in all the fields of activities. Next method is catalytic hydrogenation. The most efficient catalysts are metals from platinum group like platinum and palladium. The temperature shouldn't exceed 500 degrees Celsius. On the basis of the research that was done at the Research Institute of Oxygen Machine Building, an industrial unit was created for purification of raw argon. These units are used since 1957, and they're called UTA unit for technical argon. It's being upgraded nowadays, and there are now units RT 0.75 and RT 1.1. The main difference, well, there's practically no difference in the workflow, but they have bigger capacity, the modern ones, 0.75 and 1.1. The third method is the usage of zeolites. They are used for purification of argon from oxygen. Mainly, there are used artificial zeolites. There are natural ones as well, like limonite, modernite, etc. At the temperature minus 183 degrees Celsius, zeolites absorbs argon but not oxygen. Hence, we get purification and obtain pure argon. Finally, the content of nitrogen shouldn't exceed 0.1%, and oxygen shouldn't be more than promille. Well, thus, using this method, we can use argon in nearly all the fields of activity where supreme brand is necessary. A very important point regarding the purification of argon is a searching of new innovative methods. So attempts were made using freezing, the physical method. Of course, the freezing temperature of argon differs from that of nitrogen and oxygen. You can see the relevant figures on the slide. So far, this method is not being used. In conclusion, I'd like to tell you that all the methods used for purification of argon have certain drawbacks and difficulties. The units existing are either too complicated or too expensive, or they do not provide the necessary level of purity of argon. So at present, there are continued attempts to find modern methods of obtaining pure oxygen. That's it. Thank you for the attention. Your questions are welcome.
Thank you very much for your talk. And dear audience, do you have any questions to our speaker? No questions? Okay, may I ask you, would you like to be asked in English or in Russian? In English, okay. There are many talks about sustainable production and environmental friendly methods of production. So you said us about 3 methods of argon purification. Which one of them, since they are all got disadvantages, maybe some of them are more environmental friendly than others?
I will answer in Russian. The most common method being used is rectification. That's the most efficient method, but it also has its drawbacks. It's very expensive and sometimes very complicated. Actually, there is quite a big number of patents in the field, but some drawbacks pop up. I'm now dealing with the topic. That's my scientific work. New methods are coming, but that's a commercial secret yet. We're trying to obtain something new, innovative, and say best.
You can say about it. Okay, thank you very much for your talk once again, and we are ready to invite our next speaker. Thank you.
Thank you very much, Mr. Prokofiev. Our next speaker is going to be Maxim Semenov from Kazan State Power Engineering University. Specializing in electrical engineering, Mr. Semenov, you're welcome.
Good day.
Hello.
Can you see my presentation?
Yes, everything is fine.
Dear experts and conference participants, I'm the student of the Kazan Energy University, Maxim Semenov. I'll tell you on the influence of grounded transformers on the sensitivity of distance protection against short circuits on Earth. Well, the distance protection from shortcuts to the Earth or grounded is now beginning to be developed in Russia. So we are not using all the existing opportunities yet. One of the drawbacks is usage of this protection for the lines with the grounded transformers installed on the substations of the protected line. And there's additional fall of the load that is caused by such groundings. Thus, there may be selective blackouts of the lines. Everything is based on the Ohm law compensation coefficient. The distance switching off is using the zero consequence current that only appears in such a kind of a short circuit. Remote protection operation of lines with grounded transformers on desoldering. Well, there may be also the short circuit. It depends on the system currents C1 and the transformer. The distance protection against the short circuit to the ground is the usage of grounded transformer. That's the model of the system provided on the line. The protection shall be on a line N1 or H1. It has 2 branch lines to the transformer. That's the place of protection installation. Modeling shall be done like it's provided on the slide. Let's take a look at the work of the distance protection at switched off transformer. The first step is roughly 85% of the model line. Short circuit point is located at the same distance. And the protection will work, then the line shall be switched off non-selectively when all the transformers are switched off. That's one mode. The second mode is then when the T1 and T2 transformers are switched off. It's 30 kilometers away from the protection point. You can see that the protection did not work. The resistance measurement, the sensitivity is not sufficient. That's the transient current for the grounding to the earth. The left is when all the transformers are switched off. The second is when the T2 transformer is switched off. On the feeding is coming from the T2 transformer. Let's assess the influence of the T3 transformer that is installed at the local substation. When it's switched on, the resistance shall get increased by the part of the ohm, but that's sufficient for non-working of the protection, especially if the point is in the end of the zone of the distance protection. The solution is to change the coefficient of compensation for each mode. And that's the empirically. Let's find the modified coefficients. They all went up, and the biggest value is for the mode when all the transformers are switched on. The mode when T1 is switched off is a bit lower. The bigger the transformer, the bigger is the impact. Also, the distance protection against grounding with grounded transformers may be erroneous. Modification of compensation coefficient may improve the work of the protection. Calculation of those coefficients is rather difficult. The next stage of my work shall be deriving the formula for the calculation of the compensation coefficient. Thank you for the attention.
In your presentation. So do we have questions in our audience, from our audience? Yes, please.
Any questions?
Yes, we do have questions here in the room.
I'm Abdulkhakov from LT. When developing the protection system, did you consider the probability of the periodic part of the current appearance? Yes, we did. You can see it on the diagram of currents. We considered not only the periodic part, it was considered, but it's not used for this kind of protection. I understand you. Thank you.
Thank you for your question and your answer. Any other questions?
Thank you.
Okay, thank you for your presentation and your talk. And let's go to the next speaker.
Yes, thank you. Our next speaker is Ruslan Migranov from the Faculty of Industrial Automation and Electrical Engineering here at LETSI. Mr. Migranov.
Good day.
Yes, hello, you are welcome.
Can you see my presentation?
Презентация видно?
Yes, everything's fine, please.
So, good afternoon, dear listeners. The title of my presentation is Investigation of the Unloading of Damping Regulators in the Method of Virtual Synchronous Generator. Modern trends lead to an increase in the number of introduced alternative and renewable DC energy sources that are connected through a voltage source inverter in parallel with the main AC network or synchronous generator. To ensure the conditions for their synchronization further long-term stable joint operation, a virtual synchronous generator method was developed, which allows the inverter to mimic the static and dynamic characteristic of AC generator. The work provides a description and structure of the investigated system of microgrid, in which the problem of the unloading of damping regulators in control system is investigated in order to improve the quality of synchronization. The purpose of this work is to study in details operation of damping regulators, which control the amplitude and phase of the output voltage on the inverter, in order to make the processes of smooth unloading their output values when they are turned off. This allows us to avoid overshoot in active and reactive power of the inverter and generator at the time of synchronization. The virtual synchronous generator method is based on the swing equation of generator. However, the inverter is a static converter, and Newton's second law for rotational motion is not applicable to it. Therefore, we write the right-hand side of the first equation through the power, dividing the torque value by the nominal desired frequency of the inverter output voltage. As a result, making the appropriate substitutions and transformations, we obtain equations describing the amplitude and frequency of the inverter's output voltage. Where the equation for calculating the amplitude has a similar form to the frequency equation, but instead of active power, we used reactive power. For the best representation of the control system, a block diagram was built, in which there are frequency and amplitude additions, which accelerates the synchronization process. Based on the literature sources used, we present formulas for calculating the main parameters of the control system. The proportional component of the damping regulators is determined by the active power, frequency, and reactive power amplitude characteristic of the synchronous generator. The virtual voltage factor K is calculated using the following formula. This coefficient is the same as the virtual moment of inertia, but in the amplitude calculation loop. And the last calculated parameter is the virtual moment of inertia, which is determined from the following ratio. We use the exact synchronization method, setting the values and criteria for the difference in frequency, phase, amplitude of the generator and inverter. The choice of criteria depends on the task at hand and the required synchronization time. As the simulation results show, a significant influence on the synchronization time in phase balancing, which repeats periodically in constant to the difference in amplitude and frequency, which fluctuates around a steady state value. Now let's consider the option of unloading the values accumulated as the output of the damping regulators. The first option is unloading according to the explanation law, but in order to prevent a steady state error in the system, we will set zero value at the controller output after a time equal to 6 tau. The second option is when the regulators can be unloaded using the following equations. We used n equal to 2 and 3. The slides show the implementation of the regulator unloading subsystem in MATLAB Simulink program, which is installed in the place of switches SW1 shown earlier in the block diagram. Also, you can see the system for regulating the phase and amplitude of the inverter output voltage. The figure shows the diagrams of the power components of the inverter, which with a change in the value of unloading time constant of the integrating component of the damping controller. It can be seen from the figure that with the large time constant, the regulation time of the transient process increases, and the overshoot value increases with the small time constants. The figures on the left show diagrams of the power component of the inverter with linear unloading, according to which there is a small overshoot at the moment of complete unloading. The figures on the right show the quadratic unloading of the regulators. In comparison with the linear unloading, it has a greater overshoot at full unloading, but has a shorter regulation time. To sum up, the investigation was carried out of the example of microgrid, in which in parallel with the generator, a DC source is connected through an inverter controlled by the method of virtual synchronous generator with modifications. Particular attention was paid to the part of control system with damping regulators in the phase and amplitude control system of the inverter in terms of their gradual shutdown. According to the result of the study, when the accumulated values at the output of damping regulators unloading according to the exponent law exponential law, we can conclude that the control time of the transient process increases with a large time constant, and the overshoot increases a small constant. Comparing all three types of logic, we can conclude that the most desirable is the use of exponential loading, since the use of linear or quadratic law negatively affects the transient process of the power components of the inverter and introduced overshoot with a big time constant. This study is intended to facilitate the synthesis of control system for inverter output voltage parameters by the method of virtual synchronous generator. So thank you for attention.
Thank you for your talk. So, dear audience, do you have any questions to our speaker? Yes, please. There is a question in the room.
My greetings. Tell me, please, in your model, did you consider the properties of real microschemes? Were there any delays, non-linearity, etc.? Yes, we introduced, so to say, we changed the intensity of the task of the operating impact. The problem is that when modeling in Simulink, the functions are very beautiful, but they do differ from practice. Everything changes when you start to do things in practice, and it changes a lot. That's it. Thank you. Thank you.
Okay. Thank you for your question and your answer. Are there any questions in chat? Okay. So we are going to thank our speaker again. So Ruslan, thank you. And thank you very much. And let's go to the next speaker.
Thank you very much. Our next speaker is Andrey Ochlopkov from Moscow Power Engineering University. He's working as an assistant at the Department of Heat Engineering. He's specializing in power plants. Mr. Ochlopkov, you are welcome. Should be in our chat. Okay, I guess then if Mr. Ochlopkov is not here, what about Irina Ivanova from St. Petersburg Electrotechnical University? Is she ready to make the report?
Alexander, these people are missing, right?
All right, then we are going to invite Mr. Ochlopkov's colleague from Moscow Power Engineering University. His name is Andrey Chepiga. He should be with us. And in 2021, he became one of the winners of project Energy of Development by Rushydro. Mr. Chepiga, you're welcome.
Good day, dear colleagues. My name is Andrey Chepiga. I'm from the National Research University. Called me. The topic is stabilization of output power and increase of efficiency of wind turbines by means of the control system improvement. Well, first of all, I'd like to tell you the history of the issue, why we had the idea. In my native region, Donbass, in the year 14, there started a military conflict. That is why the wind park with the capacity of 105 megawatt went out of operation till the year 19. In the year 19, a decision was made to resume energy production, but it turned impossible due to the lack of experts in this field. There were no experts left in the field. They moved to Ukraine, and there was no methodology for training of experts for the operation of the wind turbines. Hence, a decision was made to develop quite a new energy-efficient system of operation of this facility and to create a model for training of experts in the field. Well, this research may be subdivided into the following stages: structure of the wind turbine control system, synthesis of the wind wheel speed regulator or controller, also consideration of aerodynamic properties of the wind wheel, simulation results, checkup, and design of a simulation model of a wind turbine. You can see the structure of the operation system. It consists of two areas. The first contour is the regulation of the torque of the wind wheel. It's a classical vector structure familiar to everybody. Two current regulators along the DQ axis tuned for the optimum. The second contour is of the greatest interest. That's the regulation of the wind wheel speed. It has two regulators or controllers. The first controller is controlling the unit of the rotation of the blades, and then there's the controller of the speed of the wind wheel that enables us to stabilize the output capacity of the facility. Also, on the slide, you see the structure of this controller. It's a PE controller tuned to the symmetrical optimum. However, here you see the process of synthesis of this controller. We know that the wind wheel is a nonlinear object. Hence, we have decided to make this controller adaptive. For that, neural network was employed. The input parameter for the network was the parameter of the speed that depends on the speed of the wind, the speed of the generator, and the radius of the blade. The second coefficient is the derivative of the blade rotation angle. Thus, we determined the coefficient of capacity of the generator depended on the blade efficiency. So we did the recalculation at each period of basis, the parameters of the speed controller, and thus its output. Here you see the simulation results of the tuned system MATLAB Simulink in the main modes of operation. The ones like the startup mode, partial load, and full load modes. It should be mentioned that the developed system is only switched on in the full load mode, and this you can see by the typical modification of the blade turn angle. Theory is theory, but we wanted to check the developed system in practice. For that, an experimental stand was developed that simulates the main modes of operation of the wind generator. One machine simulated the very generator. The second imitated the wind load onto the generator, applied to the generator. You can see the way it looks, this unit for simulation. The operation system for this unit was a controller schematic S7300. The dynamics converters were used. Here are the results of the simulation model. At the moment of time 1, the system begins operating. The angle of blade turn is modified, so the speed of generator and the torque moment fluctuation takes place, but we shouldn't be concerned because the output capacity stabilizes, and it's according to the government standards. A conclusion may be made that the operation system was well set and adjusted. It was done correctly. We checked both theory with MATLAB Simulink and the reality at the stand. And this stand is already used for training of experts in operation of wind turbines. And we're going to use it at the very facility, Novazovsk Wind Park. Thanks for the attention. Questions are welcome. Here are my contacts if you have questions later.
Thank you. Thank you for your talk and your presentation. So, dear audience, are there any questions to our speaker? Okay. Do we have some questions in chat?
There is a question in chat. With the help of the wind wheel, you managed. Did you manage to restore Donbass, and did you train new experts? If not, how much time will it take? And why there was no education system for the previous turbine system? The education system did exist, but when the conflict started, some 70% of teachers moved away. Thus, the experts in the field simply left the region. Training may take roughly half a year. This simulation model included the refresher courses, and we did some lab models. So we're going to do the training.
Okay. So thank you very much for your talk and your presentation.
Спасибо большое.
Let's welcome our next speaker.
Yes, thank you very much. Very informative. Do we have Timur Valiev in the audience at the moment? From Noyabrsk Energoneft?
Yes, yes.
Do we have, or is in the Zoom chat? All right. So he's going to be our next speaker then. As I've said, he's from Noyabrsk Energoneft, subsidiary of Gazprom Neft. He is to give a presentation on making changes in the unloading of the generators and power plants. Mr. Valiev, you are welcome.
Good day, dear colleagues. I'm Timur Valiev, and I'll tell you on changing the method of unloading generations and station. The biggest failure for autonomy is the switching off of one or more generators that work in parallel, and that causes the shutdown of production. And when the frequency goes down, some automation elements may be ineffective. The frequency may go down abruptly, down to the last trip set point. Thus, the already unloading station keeps being shut down. And there are other reasons for inefficiency. First of all, is the high inertia of regulators of energy carriers providing. The jets cannot open instantly and bring the gas to the turbine blades. The other reason is that excitation system cannot start the huge generator instantly. Also, there is a small reserve of capacity. We can't have from 3 to 7 machines in reserve to provide the network stability. Take a look at reality. It's on the slide. That's the oscillography of the shutdown. Most interesting is time mark R2. That's the trip set point of the system of automation for closing of the gas valve, stopping gas valve. Thus, yet before the loads were switched off, the feeding was stopped. That's R3 and 4. To minimize such shutdowns that make the company suffer economically, a different system is necessary. That was my project about. The goals and objectives is to eliminate complete shutdowns of autonomous power plants to ensure uninterrupted power supply to the oil and gas complex. We need to wait till the frequency goes down till the trip set point. My system doesn't wait for that time. It works faster. And we obtained that by using fiber optics and programmed logical controllers. The last resolves the other two tasks. That's the parameter table and dosed unloading or curtailment. Automation is necessary for that, or curtailment or unloading that is described on the next slide. The system consists of 3 blocks, the measurement, the logical, and the executive one. The measurement block has the automation and the parameter table. Logical block is programmed logical controllers. The output chains are switched to the executive block, and the executive block may have as many substations of any class of any kind. It's important that the board is installed with automation on that substation with a fiber optic communication for fast communication. Take a look at the algorithm of work of the unloading. We start with the collection of initial data. We used programmed logical controllers and converters, so we register the input parameters into the system. Next step is analysis of blocking and protective signals and shutdown signals. After that, there's initialization of the number of the switched off units, and we assess the possible deficit. We identify the possible deficit by comparing the maximum parameters of capacity with the consumption. And then we determine who to switch off. They are selected so that the total load is 2-3% more than the existing deficit. Also, we consider categories. Next is the executive stage. We impact the cells of distribution devices. The signal via fiber optics goes to the boards at each substation. There, the signal is converted and is sent to the cells previously determined. The algorithm is finished if the generated and consumed capacity or power is equal. Selection for switching off of the consumers. Well, we select the least important consumers. Their switching off will not cause serious economic losses, and they don't impact the technological processes. And after the additional generator started, these consumers may be switched on in half an hour. This algorithm is using the controller, so I should use it. It's a simplified model of a computer that uses a certain algorithm to resolve its tasks. Several criteria are important. The memory, the quickness, the price, and the number of inputs, outputs, over 1200. As for the three other parameters, we did the analytics. Siemens S7400 is the most suitable one. I talked about prices. Let's switch to investments. They provided on this slide. The total amount for 3 substations and 1 station is 33,400,000. And it includes the feasibility study, the cost of the equipment, installation and commissioning and putting into operation, programming, etc. And that's the payback period provided. The payback period is 2.8 years for a certain deposit. It's not that much for such a system. In conclusion, I should say that the prevention of complete shutdowns is possible when using the modern systems of unloading of the system and the systems of loading that don't have delays and no trips at points by frequency. If we use a more modern parameter table, we'll be reacting more flexibly to the deficit. There'll be less shutdowns.
Thank you
Thanks
for your
for the
talk
attention.
and presentation. Very interesting. So, dear audience, do you have any questions?
I'm Alexander from Yabarska Energoneft. Good day, colleagues and Timur. I have 2 questions. First, what's your opinion? How difficult it will be to adapt this project to the energy facilities with gas pistons units as main elements? It should be mentioned that the gas piston units have their own operation system. And if it's integrated with the existing system of curtailment or uploading, good results may be achieved. The system shall react faster, thus the harm shall be minimized. Thank you. Second question. Considering the positive results of your scientific research, I mean the transfer from Siemens equipment to locally produced equipment. There's already the integration into the system. Something is installed. I know it's the Siemens equipment used and installed at your deposit, at your field. But if you consider that the local unit will not have the protocol conflict, and we won't lose in the reaction time of the protection system. If we lose, then we lose very little. Do you think we should regard transfer to the locally produced equipment? That's why we have the feasibility study as part of our project. We are studying all the options and opportunities and possibilities, and we think what is best to upscale our project to disseminate it wider.
Thank you for your questions and your answer. We thank you again for your presentation and your talk. And now it's time to conclude the first part of our session, and we can go for a coffee break.
Yes, the session will resume in 30 minutes. Thank you for your time. The first one, the name of the section is the digital transformation of energy companies, plus we continue the energy efficient solutions. And Maxim Sitnikov from LETI, he's a graduate of the Faculty of Industrial Automation from the Electrical Engineering here. He's a winner of multiple student contests. He is the head of the student section of IEEE at LETI. And in 2020, he devised a laboratory course in MATLAB Simulink. Mr. Sitnikov is here with us. He's going to give his presentation in person. We welcome him.
Good day, dear conference participants, dear Zoom audience. I have 2 presentations today. We'll start with trends and new challenges in the field of energy efficiency of electric machines. It's dedicated to the survey of the modern legislation in the field of energy efficiency, the current and the new coming, as well as to the energy efficiency and the comparative analysis of using energy efficient engines at production. Energetics is very important in our lives. We are all using the products of the energy industry, and year after year the consumption of energy keeps growing. Hence, we need to develop new solutions in the field of energy efficiency and rational usage of energy resources. That's explained by global trends like globalization, urbanization, demographic, and climate changes. It should be mentioned that there is now less oil and gas, and energy carriers grow in price. The consumption of energy is growing, plus there are CO2 emissions. So we need to learn to use in a rational and efficient way what we have now. Well, examples. Some 43% of all the energy consumption is from industry, and a lot is used by electric engines and electric drives. Thus, if we save a bit, we shall win a lot for the whole energy industry. Should say that the key parameter to achieve energy efficiency is a comprehensive approach. If on the level of the product we can save some 10% of energy, if we adapt and modernize, upgrade the system, we can increase the general energy efficiency by some 30–60%. Much higher. Now, what is energy efficiency? The main parameter, as you know, is the efficiency. What's its difference from energy efficiency? It's a curve of dependence of efficiency from the active power. So it's just one of the parameters of this indicator. Talking about standards, there exist several. First is MEMA standard. It's rather American. It's not directly related to us. My presentation, I'd like to mention that since the 1st of July of this year, of the year 21, we have introduced a new MEP standard in the field of energy efficiency. What's the main difference of this standard? There are 5 classes of electric machines determined judging by the energy efficiency. And there are the relevant indicators. And for the first time, there's the notion of energy efficiency of class 4 and 5. On this slide, you can see these classes. There are 5 from IE1 up to IE5. Most common in our industry are the first ones, IE1 and IE2. Now they transfer to 3 and 4. As for IE5, it's for asynchronous electric drive systems. They are not yet achievable nowadays. Now trends for changes in the regulations. EU nowadays the minimum class is IE2 for high power engines. It's IE3 with efficiency of 95% and higher. Since July of the year 23, that standard shall be modified as well, and the minimum one for the big systems shall be IE4. In Russia, it should be mentioned that till nowadays we have no norms on energy efficiency so far. We use just efficiency. But since the year 22, 24 and 26, a minimum parameters are introduced. So since the year 22, it shall be IE2. Since the year 24 and 26, the minimum shall be IE3 for all the electric drive systems of average and high capacity. Here are modifications of the legislation planned. You can see that since the 1st of July of the year 23, the class IE3 shall be compulsory and the main one. As for the E5 class, it's achievable, but only if we use synchronous reactive drive, synchronous reluctance. It's much better than asynchronous engines. The drawback is that the frequency transformer or converter is necessary, but this is paid back by high efficiency. How can we improve the energy efficiency of an electric motor? First of all, we can use additive technologies. They enable to get composite materials. We can use new types of insulation, improve aerodynamic properties of rotors, improving geometry and topology. We can increase the accuracy of the bearings to bring down the friction, and we can use frequency converters. Well, in this article, we tried to compare two engines of Siemens company. Why Siemens? The simple answer, besides being the postgraduate of LIT, I also work as an engineer in Siemens company. At present, Siemens and ABB are the two flagships of European energy efficiency. So we compared two engines with a power of 55 kilowatt of class IE2 and IE3. The price is different, 12,396 and some 14,000 euros. On this slide, you can see the internal software, let's say, and when using the IE3 engines, we can save some 6 megawatt. And Siemens engines are supposed to work for some 25 years with good technical servicing. It may be a longer term. So in 25 years, we can save 12,630 euros. This is the same price as the price of the IE1 engine. And if we service it well, we can save even more. In conclusion, energy efficiency is a trend, and in Russia, a relevant strategy was adopted till the year 35. That's why, with the government support, we can have quite good achievements in the field of energy efficiency. Thank you for the attention. Questions are welcome.
Thank you for a great opening talk of this section. So, dear audience, do we have any questions? Okay, do we have questions in chat?
Yes, we have a question in the chat. Whether the bringing down of the power is related to the better topology.
I suppose it will be a talk of your second presentation. Exactly.
Well, as for this question, I will briefly answer it because my next presentation is about the optimization of rotor topology. Yes, if we optimize it, we may lose some power, but thus we can win in efficiency. But that will be the topic of my next presentation.
Thank you for your question and your answer. So let's end the speaker, and we are ready to invite our next speaker.
Thank you very much. We have our next speaker, who is Lyudmila Kozlova. She is a PhD in technical sciences and assistant professor of Department of Robotics and Automation at St. Petersburg Technical University. And after her, we are going to have Irina Ivanova, also from LITSI. Please be ready to make your presentation after that. Thank you. Please stick to the timing, 7 minutes for your speech, 3 minutes for questions. Thank you.
Good evening, dear audience, dear participants. I'll tell you about the fuzzy logic application in solar panels. At present, the usage of solar panels is becoming very popular. Why that? The previous speaker mentioned that we are running out of oil and gas. Prices for electricity keep growing. Hence, the solar panels are getting more and more popular. Modern solar panels, if we are talking not about the household ones used in private homes, if we talk about the solar panels that are used industrially, then such panels are comprehensive technical systems with certain fuzzy parameters, the ones that can't be determined distinctly. Hence, the efficiency of solar panels depends on the amount of sunlight, on temperature, on the season, and on different weather conditions, and on mutual positioning between the panels and the sun. Well, in this study, there's the two-axis system of monitoring and the usage of the step engine. We've analyzed the systems of the other authors. Well, they are coaxial systems, but they don't have the step engines. Instead, they are using the direct current engines, and they have certain drawbacks. We regarded a system with steppers. On this slide, you see the simplified diagram explaining how these steppers are operated. There are engines installed on the frame, and they change the angles of the azimuth and the location. When the panel temperature changes, it's necessary to timely modify its position to get maximum power. Maximum power depends on the volt-ampere indicators, so it may be varied, modified by changing of the panel position. The system of surveillance may be recorded as a fuzzy model, and a number of rules should be used, including the knowledge of temperature, intensity of solar irradiation. Some other factors may be included, but in this study we just regarded dependence on temperature and intensity of solar irradiation. If we take certain space U and approximate it to the finite space of some fuzzy commands, here is the dependence you get. You see it on the screen. Well, one of the possible values of the vector of the fuzzy variable is considered in the function that we'll regard a bit later. Using fuzzy logics provides that we use fuzzy indicators that describe the system directly instead of the non-fuzzy ones. So, certain description of the object is done linguistically, linguistic variable. Each of them sets certain descriptions of the object. So the solution shall consist of 4 main stages. The first stage is fuzzification, making fuzzy. Then we make a logical conclusion. Then we compose the solution and then do a defuzzification. The meaning of this method is looking for the error of controller and modification relating the iteration that will be done by the controllers. On this drawing, you see the 4 fuzzy subsets. They are used to derive the necessary variable. There could be not 4 but 5 fuzzy subsets if we included also very cold weather. Very cold would be below minus 30 centigrade. Well, thus you can provide the linguistic variables. When talking about the system operation that includes the step engines, it's necessary to regard a system of equations that describes the activity of the step engine. But a little peculiarity, the mechanic characteristics or description of the step engine includes 2 bad parts or sides. One is of resonance and the second is of hysteresis. So for the operation to be good, it's necessary to find the optimum site where the resonance site and hysteresis sites won't be switched on. Here you see the system of differential equations to describe the step engine and the conditions for not getting into those edge sites. On this slide, you see the mathematical model made in MATLAB Simulink. We used it for simulation. In conclusion, let me tell you the following. The transition description that you see, or the output signal, is the left diagram, while same of the engine is the right diagram. The results of simulation provide that the solar panel makes or gets the necessary angle, and the time of transition is 0.015 of a second. There's a big benefit of using step engines. That is, if we use them, it will enable us to provide precise positioning of the solar panels. There is a high speed of start, which can be done with the DC engine, the reverse, the stopping, and the high reliability due to no friction parts. Thank you.
Thank you for your talk and your presentation. Dear audience, do you have any questions? Yes, please.
Good day. I have the following question. It's not quite clear. Why did you use fuzzy logics here? If we are using the temperature sensor on the solar panel, why can't we simply have a classical structure or design, usual commutation for the step engine, while the input signal shall be the setting of the position? We cannot determine precise position due to the fact that there may be different exciting impacts on the solar panel. We can't forecast when it will be sunny or rainy, or when there will be snow in winter. So we have certain parameters that cannot be set. There is a certain level of uncertainty And if traditional methods are used, then we have to definitely determine the parameters that our system depends on. But we can't do it. We can't predict the weather precisely. Thus, two methods are possible, either using fuzzy logic or neural networks. Neural networks are also popular, and they are used in cases when certain parameters cannot be preset. From the list, we can only set one parameter, that's the movement of the sun from east to west. The rest, the temperature of the panels, the intensity of sun radiation is unpredictable. Thus, fuzzy logic enables us to resolve this task. Thank you. Once more, small question. The settings of fuzzy regulators is done using method Momkani or Sugena? Sugena method. In this study, we used Sugena method. Why? I simply preferred it. That's why. We did not have time to compare the two methods, Sugena and Magdani. Thank you.
Thank you for your question and your answers. Seems like a new promising research. Thank you for your talk, and let's invite our next speaker.
Yes, thank you, Lyudmila Petrovna. Very, very informative. We are going to welcome Irina Ivanova, also from St. Petersburg Electrotechnical University. She's going to give a presentation on the risk assessment of service processes for sustainable development of the company. Ms. Ivanova, you are welcome.
Slideshow doesn't seem to work.
Okay, you can do it like this. It's still visible. Thank you.
The main motto of modern world is striving into the future. If we regard the sustainable development from the point of view of quality management, it's an integrated management system. That's integration from the point of view environment, society, and social point of view. And that's the standard 14,001, 9,000 from the point of view of economy, and social 45,001. If we talk about the sustainable development for the energy companies, then it's this kind of diagram that you get, and it includes 5001. This is the standard for energy management. The study is topical because I've chosen electric energetics. And within the GDP of Russia in the year 20, it made 2.6%. That's an important input. Also, since the year 2009, there was introduced the energy strategy. Now it's extended till the year 35. Its main position is the development of energy sector within the regions and in the country. Well, what are the main requirements of this standard ISO 50001? The companies need to consider and to manage the risks. Here comes the question, how to do it. We can subdivide the processes of energy activity or of the company into the industrial, technological, sales and service processes. The service field is rather comprehensive. Its processes are rather bureaucratic, expensive, and they provide high communication. That is a difficulty for management. We have the risk assessment standard, 31,000. First stage is risk identification, next comes the analysis, next is the risk evaluation. The problem is about the following. if the service processes are regarded for risks. Communication problem, the process may be rather difficult. That's why it will be more difficult to research, to study it. Also, for the common scheme of processes, it's very problematic to get it described, and the data obtained is both quantitative and qualitative. We've processed the analysis and chose the following methods. The basic is FMEA analysis. That's failure mode and effects analysis. Well, we've chosen FMEA for the system. The system is taken and then the research is done, the analysis is done inside it and regarding the processes. Say the system is a car, the process is assemblage, and the FMEA is for the details, it won't be used. It's a very conditional algorithm. And that's a preparatory stage, analytical stage, and the description of the implemented events. So the cycle is as follows. If our methods weren't effective, then they're repeated once again. The results, the key components influence the results. It's used successfully. It's mentioned in foreign articles in healthcare, and the successful usage for the processes of logistics. This analysis is successfully used in automotive and aviation industry. That's it with my presentation.
Thank you for your talk and presentation. Dear audience, do you have any questions? Do we have any questions in chat? No, we have a question in the audience. Okay, great.
Thank you for the presentation. Here is the question. You've mentioned, described a certain management system, and you mentioned plenty of different standards. I'm interested in the following. What tools are used to achieve certain different levels? Systemic level, the sample method, etc. Haven't heard that. In general, we've made the study of the quality management system. In the beginning, we just take a company and study certain problems, issues within it, not as a system, but rather the processes that are subdivided. So I didn't take industrial, technological, only part of the system was separated from the whole company. So you took the already integrated company with systems existing. No, the systems are not yet existing, because at the level, present day level of development in Russia, very small number of organizations use the 4 types of standards. Mainly, the standard used in Russia is 9001. It's used everywhere. In many companies, there's also the 14,001 and 45,000. I believe in Gazprom, they also use the standard 50,001. Yes, it's used in Gazprom. They do have the integrated management system. Thank you for the information.
Thank you. Thank you for question and answer. I see that we have a question in chat, right?
I can see this question in chat. I can answer it. In principle, yes.
Have you tried to apply the FMEA analysis method to any organization?
Yes, we did already try to use the FMEA. I was rather an assistant in this part, because a big team is organized just for the industrial processes, not for the services. Services is something new, so there are no publications on this topic yet.
Okay, thank you. Thank you. Thank you for your talk, and we are ready to go for the next speaker. Thank you.
Thank you so much. We should invite our next speaker, who is going to be Timur Valiev from Noyabrsk Energoneft, a subsidiary of Gazprom Net. Will. All right. We should invite Maxim Sitnikov then with his wonderful presentation on roses. Let me remind you that Maxim Sitnikov is a very distinguished student, and he received multiple prizes and stipends during his studies.
My greetings again, dear colleagues. Let's continue discussing the energy efficiency of electric machines. I'll tell you about optimization of the high-speed synchronous reluctance machines geometry. In my previous presentation, I mentioned that most promising are synchronous reactive drives, but not just that. Special attention is paid in Europe to machines with a high rotor speed of rotation, over 10,000 RPM. And synchronous engines are popular with permanent magnets. They are necessary to overcome certain difficulties. In our work, we studied the synchronous reactive machines, and in my master thesis, we've studied such an engine. The most promising topology is provided on the slide. The problems arising here are mechanical stresses in the rigidity ribs. Here it's around 1,000 megapascal. Such a rotor shall fall apart at the RPM of 31,500, and the necessary power is 130 kilowatt. Hence, we suggested topology optimization. It may be subdivided into two notions. First, optimization in problems of solid mechanics. The target function is the Young model, and we did such studies earlier. Constant multiphysics works within the framework of test and try. It can tell which materials will be more efficient. The second is optimization in problems electromagnetism. The target function is the magnet properties of the ferromagnetic sites of the machine. The theory is as follows. There are two approaches for minimization of mechanical stresses on the rotor. There is elastic energy density and the peak stress using domain probe. Such are the main approaches. And we can bring down the common energy that appears at stress, and the peak stress may be traced using the probe, and thus we can try to minimize it. Target function, we need for that limitations. Limitation was the distribution of mass density distributed by volume. On this slide, you see the result of optimization. The energy of plastic deformation with the following limitation. Distribution of mass is 40 kilograms per meter. In the center, it's resolved, but at periphery, some 400 or more of megapascal are left. If we optimize via the maximum mechanical stress, this topology, yes, at periphery we've resolved it, but the rigidity ribs are still problematic. I believe the most successful experiment if we try to minimize the energy of plastic deformation while the mass limitation is remaining to be 30 kilograms per meter. That's quite a successful topology. Well, if we try to optimize the peak stress of the rotor with limitation of 30 kilograms per meter, something not realistic is obtained, so we didn't regard that. If we try to maximize the electromagnetic torque, then we get a kind of a petal geometry. It provides maximum moments, plus it counts big pulsations of electromagnetic torque. This is not good, so we didn't regard that geometry as well. Thus, we can suggest the transfer from this to that geometry. And as for the electromagnetic comparison, we've studied the angle characteristics of synchronous reactive machine. Its main indicator is the load indicator. For the first, it's around 110 Newton per meter. That was the torque. For the second optimized machine, it's around 70 Newton per meter. Yes, we lost a bit in power, but the first machine wasn't realistic at all. And thus, we've increased the pulsation of the torque. It's now 90%, 90, though initially it was only 15. This topology may be additionally improved if we consider the distribution of magnetic field by the rotor volume and add certain elements into the already developed topology. It will not impact the mechanical stress at all, but as for pulsation, it will be impacted a bit. It was 90, now it's 80%. While the angle indicator is the same. It was and is 70, no changes. Pulsation torque may be additionally brought down if in these small gaps we introduce permanent magnets, so it will be synchronous reactive engine with a permanent magnets. Thus the pulsation is already 72%. It may be additionally brought down. Yes, at first it seems like pulsation is pretty high, around 80%, but it may be used without the frequency converters, and yes, we can use it with such converters that will provide an additional improvement of all the indicators. And the main conclusion is the high-speed synchronous reactive machine may be created and used without any problems. Thank you, colleagues. Some questions are welcome.
And I see we've got a question, like immediate question. Yes, please.
Once again, good day. I have a question. How to operate such machines? The interpreter apologizes, the sound is very bad. The question is hard to hear. Different speeds, flows of machines. What about, did you research that? Yes, we did research that, and it was part of my master thesis. In this system, it's around 0.6, while the efficiency is 97%. That's funny, but the study of high-speed machines in the area of asynchronous ones, the leader is the Lappeenranta University of Finland, headed by Professor Pirhanen. For the high-speed asynchronous machines, it's 0.58. My machine is 0.6. It's usable in principle, and probably its operation is much more effective than of the other compared synchronous systems. Also, the role of the frequency converter is not considered. That may regulate the coefficient of power or capacity. Cosinus phi for the whole system may be much higher than in a separate electric engine. This should be considered as well. Thank you. Cosinus phi for this machine is necessary as the initial value to begin with. I didn't study cosinus phi as systemic in this study. It's the one of the machine without the frequency converter. I'm thinking about the machines at production. May I make my last comment? The company, APP, high-speed electric machines for the defense industry, they are using them, and they are not concerned about the initial cosinus phi of 0.6. For Russia, it may be something abstract. Around 50 watts, they study the engines. But for our Finnish colleagues, that's something habitual already. They are used to it.
Thank you for your question and your answer and presentation. So let's thank the speaker, and we are ready for a new talk.
Yes, very enlightening discussion. Another question for the speaker.
I suppose you can address it in person.
I have a short question. A very interesting study on electric engines. What about operation and what should be their technical condition? I can tell you a bit that this is the master thesis done with the assistance of professor from Aalto University. They specialize on the analysis of the technical condition. They are using, first of all, the neural networks. In such machines, first of all, the bearings get broken at such high speeds. So they have the neural network programming. They analyzing the currents in the bearings, and they may forecast the breakage of the machine. In Lapinranta University, they do the same, but in the field of conductors. So classical methods are used for the analysis, right? Yeah, the operation of sensors at such speeds is also studied, but that's a bit more difficult. Sensors at high speeds, here it's 30,000 RPM, but what if it's 100 RPM, 100,000? That's, that's extreme.
Thank you, Mr. Sitnikov. Your work here is very appreciated. Our next speaker is going to be Alexander Volynets from Noyabrsk Energoneft, a subsidiary of Gazprom Neft, here to give the presentation on the scheme of emergency automation of power complexes based on the Alexander Zhagrin oil deposit. You are welcome, Mr. Volynets.
My greetings, dear colleagues. I'm Alexander Volynets. I'm working at Priobsk Neft company. I'm the head of dispatching service. Here is the scheme of emergency automation of power complexes based on the field named after Alexander Zhagrin. So be happy to take your questions later on. GPN company has lots of different fields and deposits. Many are not related to the energy systems of Russia. The independent and the electric power has to be generated on their own. The main source is diesel, gas piston and gas turbine electric stations. In this project, we disclose the problem and the solution for the gas piston electric station. Such stations are widely used at such deposits. Gazprom Neft or GPN is widely using such facilities produced by General Electric Vakesh company. And they may work using different gas fuel. In Russia, some 700 gas piston engines of General Electric are working. Total capacity is 1.51 megawatt. And the number of such units keeps growing in Russia. So the issue is topical. At the Zhagrin field, the source of electricity is the autonomous energy complex. Its main element is Vakesh electric station. For fuel, they use flame gas. And they have the step-up substation, 6.35 kilowatts in winter. They provide the electricity for the production. However, disregarding the high level of reliability, the shutdowns are possible. The shutdowns are caused by deficit of power. We've analyzed the stability of electric supply and found out the main reasons of the failing of to produce oil. We have statistics of growth of emergency shutdowns that cause the bringing down of oil production. The main reason is the stopping of the electric engine due to emergency shutdowns. Shutdowns are caused by too high loads and no reserve capacities. To have a big reserve of capacity as a hot reserve, that's not efficient. Hence, shutdowns are possible, and that's a loss of the production of oil. There exists the anti-shutdown automation. That's the frequency discharge in 5 seconds if the load is too high and the complex doesn't work normally. The level of the frequency of the network in the pre-emergency mode remains the same. Hence, the anti-shutdown devices do not work timely. This project is aimed at the solution of this problem. Then has a different principle of work, and the algorithm is performed in minimum time. Hence, the emergency shutdowns are prevented. Here is the scheme of the anti-shutdown automation. That's the model of data processing with communication and operation channels. The task is to create the technical basis, including communication channels between the energy complex, the data processing modules, and the operation station, with a partial usage of the already existing equipment. We've adapted everything for peculiarities of the local place. We've done the setting of the communication channels and analyzed the results to determine the scaling of using of this technology. The quick action of the system depends on its components. It consists of the following components. The module for data processing. Controller demands it has to create a big number of main channels of signal transfer from the master to slave units. High speed of processing is necessary, and we use fiber optics. We also need to have adapted software for programming of the algorithms by the personnel. When looking for equipment, we looked at Siemens company and looked for the local similar producers. When choosing controllers, we use Simatic Siemens 300, 400, PLC Ares, and PLC Regul R15, made by Microsoft Systems. We chose the multifunctional module controller Ares and PLC Regul R500. They're designed to solve automation issues. Communication channels, choice Alpha Regul, good software made by the Russian producers, and Regul PLC system provides the processing and analysis of data necessary to calculate the load of the energy complex, to find out the deficit and deviation of the network parameter. These are the components of the system that we have chosen. Discrete and analog communication channels, module controller, processing of data on how the complex works using the software on the basis of the complex alpha platform. Then the transfer of the operating signals and the transfer of the signals via the communication units and walls to the controllers of transformer substations. The final stage shall be the transfer of these signals to the discrete input of the operation station to impact the mode of work of the equipment of the consumers, and for restoration of the normal mode. This system of anti-shutdown automation involves the different facilities, and it considers the temperature and other parameters. The system forms the operating impact, like switching off of the consumers, speeding up of the protection, etc. Everything shall be done according to the preset schedule, and it's connected to the dispatcher system. Now about the economy of the project. The income of the company from 1 ton of oil produced according to the data of the year 21 is 21,000 rubles. If the complex is stopped, we lose on average 100 tons. In the year 20, there were 3 shutdowns that could be prevented with the automation system. That means 7 million rubles per year. In 6 months of the year 21, such losses were 500 tons. So the average in 5 years would be 330 tons or 7 million rubles per year. Expenses for introduction of our system include the research work, the technical solution, the development of the documentation, installation, and the commissioning. So the payback period is from 2 to 5 years. Afterwards, the expenses shall be much lower just for the servicing of the system. When developing this project, we've determined the problem and found the ways for its solution. We've analyzed the existing anti-shutdown measures and developed the relevant system. After this is introduced at Zhagrin deposit, we'll analyze the work of this system and determine whether it's good enough to disseminate this experience as other deposits. Well, this may be quite efficient. We believe it would be rational to introduce such a system. It will enable us to save a lot on the absence of shutdowns. Thank you.
Thank you for your presentation. Are there any questions to our speaker? Do we have questions in chat?
There's a question from the chat. In how quickly the system will switch off the load after the disturbance? At the time when the system works? Is that the question? Couldn't hear it well. It will be around 0.5 seconds. That's according to the preliminary calculations. We'll get to know the time more precisely after the research is finished and the system is introduced. Maybe the time shall be even shorter. In comparison with the existing system, even if it works slower, considering the fact that the system shall use different parameters and a different principle, it will work anyway faster and before the switching off, before the shutdown takes place.
Okay, thank you. Thank you for your answer and your talk. Let's invite our next speaker. Thank you.
Our next guest is going to be from Penza State University, and is Mr. Mikhailov. Please welcome. He's going to be joining us.
My greetings to the conference participants. Optimization of the structure of a solar power plant. So I'll talk about optimization of the structure of a solar power plant. Criteria for optimization is a rated voltage of solar panels, number of voltage stage. At present, the market of solar panels has those of different voltage from 12 to 16 volts. So we've suggested one of the options of organization of the structure of the solar power plant. Number of voltage stages, AC or DC current type to transmit electricity within the station, rated power of the modules, rated power of the transformer, substations, that I included in the structure of the power stations to bring down the losses of voltage when transmitting within the station. The rated power of the main step-up substation and location of the transformer substations and main step-up substation, where on the territory of the power station is going to be located. A bit more details on some of the items on this item. The number of voltage stages. We believed the number of transformer connections that will connect the main step-down substation with the solar panels. The example is solar panels united in lines with a nominal voltage of 48 volt, 15 panels in a line. Then we'll have the rated instant value of 754 volt. That's the instant value that will, after the transformation in the transformer substation, shall be used and shall be sent to the main step-up substation. As for the choice of current, each line of 15 panels shall be united into modules consisting of 20 lines, so that the current would be 200 ampere. Hence, each module shall generate a certain power, depending on the intensity of sun radiation, on average around 120 kilowatt per module. Electric energy shall be transmitted using the AC, and the modules shall be united at the transformer substation, where there will take place the transformation of DC into AC, and that will bring down the losses at the transfer of electric energy within the power station. It should be mentioned that if the voltage grows, the losses shall grow within the station. So our main purpose was to cut down the losses of electric energy transfer within the station.
Excuse me.
Are you changing the slides?
I'm still at this slide.
Okay, but 2 minutes left.
The method to bring down the losses within the station is installation of the transformer substations and the main step-up substation in the centers of electric generation. Determination of the location of the centers is done as something similar to determination of the locations of electric load. That's obtained from literature. We suggested to describe each single source of generation as a rotation body, described with the formula in the right part of the slide. You can also see its outlook on the slide. There's a drawing. The main difference from the basic function is the impact of distribution, the parameter of characteristics of distribution gamma in the formula, in the equation, on the external shape of distribution. So we've used a solar station consisting of 9 modules, and you see how they are located on the site. If their coordinates and voltage are provided on this slide, we see 9 modules. If distribution characteristics is improved, we see the process of uniting of the tops of the figures. In the previous studies, it was proven that the coordinates of the tops are projected exactly at the points that we would have obtained using the search of the centers of electric loads. which is described in literature, for example, in the books by Fedorov. The outlook is provided on the screen. For 9 models, we suggest to use 3 transformer substations with the coordinates that you see on the screen, and the dissipation shall create the creation of such a surface. The top of it will be in the center of electric generation. Conclusions. It should be mentioned that the rated voltage and power of the transformer substation shall be determined by the number of solar panels in one model and by the solar radiation level in this location. The rated voltage and power of the main step-up substation is determined by the number and rated power of the transformer substation. The amount of energy generated is proportional to the area of the solar power plant. The losses on the transit of electricity from panels to substation increase with increasing the solar power plant, and power losses on internal flows may be reduced by optimizing a structure of the solar power plant. Methods for determining the center of electrical loads are suitable for determining the center of electric generation. The method of distributed specific powers may be used to determine both local and global electrical generation. That means it's applicable to optimize the structure of the solar power plant. Thanks for your attention.
Спасибо за внимание.
Thank you for your talk and presentation. Do you have any questions here? I have seen a question in the chat. So what about questions here in chat?
A question in chat. Each producer of solar panels have certain instructions explaining how to install on the site those solar panels. How much do you gain in efficiency if you do use your own layout? Thanks for the question, it's clear. Well, we use the extreme case when the main step-up substation is outside the site of the solar power plant, so that we use its area at a maximum. And we assess the transfer of the shift of that substation to the center. The difference was 16%, 1/6.
Thank you. Thank you for your answer and your presentation again. So let's move to the next speaker.
Yes, next speaker is going to be Dmitry Mendeleev from the Tatenergo company from Kazan, specializing in industrial, mechanical, and environmental engineering, instrumentation, and education. He has authored multiple scientific papers. Mr. Mendeleev, you're welcome. And to every speaker, including Mr. Mendeleev, please, can you be as succinct and short as possible, because we don't have too much time left and we have to listen to quite a lot of reports still. So every minute counts. Thank you very much.
Good afternoon. Well, we strive to improve the usage of electric energy. So this is my topic: analysis of the application of electric power storage systems at thermal power plants where they may be used. We regarded using such technologies to improve the efficiency and the possibility to use the energy for own needs. The relevance and trends. We consider the accumulation of electricity, the reduction of CO2 emissions, the improvement of reliability and quality of power supply, the development of electric transport. Well, we considered the growth of consumption and the peaks forecast of growth of the world market, global market of electric power storage systems. The global market by the year 25 shall be $85 billion. By the year 40, it will be over 900 gigawatt. And there's technological progress in energy accumulation. We also are striving to bring down the CO2 emissions. So the main functions of electric power storage devices are as follows. Align load schedules in the network and dampen power fluctuations, increasing the stability of the system, stabilizing the decentralized sources of electric energy, expanding the available capacity, providing backup power supply to the main consumers in case of shutdowns, and providing reactive power compensation, frequency regulation, and active filtering. The conditions of work, well, all the produced energy is brought to the market. What about own needs of the heating stations? We buy energy at the market prices. So a question was put, why not to use the accumulators of energy so that we can later use this energy for own needs or sell the excesses at the market? So here is a 220 megawatt combined cycle power unit. It has two boilers and two steam turbine units. The additional equipment is some compressor stations and other things, the devices for technical water, some pumps, recirculation pumps, and the feeding for different units. Depending on the mode of the station work, the capacity may vary. Depends on the loads, on external conditions, on the availability of reserve and other factors. Usually it's up to 50% of the equipment capacity. To choose the correct equipment, one should make accurate calculations so that the accumulator is not idle. So what are the main components? It's in the inverter, the rechargeable batteries, power cables, modular building or container, cooling system, management system, room, land plot, foundation, fencing, the cost of construction and the cost of connecting. So we did the calculation of the use of energy storage system for equipment at a price under power supply contracts. And we believe it's going to be in a high demand. The cost should drop down to $150 per kilowatt hour. Thus, we will be able to save some 60 million rubles. And the range may differ from 3 kilowatt to 1 megawatt. We also should consider such things as reliability, serviceability, etc. Well, we calculated the usage of such accumulators for the thermal power plants within a year. And the results are provided in the table. The payback period is 10 years maximum. The system of accumulation of energy may have three mechanisms of work. The choice of capacities, providing reliability is of importance. This will have a bigger reserve, smaller expenses, and a source for own consumption, and the source for extra sales. Accumulation may be done for 5 hours per day, and we could sell energy for some 14 million rubles. So the actual payback period is around 5 years. Its operation is not that expensive. In conclusion, I can tell that new technologies are often a challenge that's encountering the unknown, but we considered the foreign experience, and I believe those systems of energy accumulation shall get more and more popular in Russia. Different options are possible, thus it may be used in different places and for different functions. Just what we need is the correct selection of equipment, since the optimal choice is always not an easy process, but it's possible. Thank you.
Thank you for your talk. So do we have any questions here in our audience? Okay, so could you please tell me, do we have a real applications of such a system on any enterprises in Russia, of course?
In Russia, no, there are no such applications yet. It's a new idea.
Okay, so I understand. Thank you. Thank you for your talk. And okay, let's invite the speaker.
Thank you very much. The next speaker is going to be Yuri Sharmatov from Novoyabrsk Neft. As previously said, a subsidiary of Gazprom Neft. Is Yuri Sharmatov, I presume he's online? Or, well, we welcome Mr. Sharmatov with his presentation on diagnostics of cable lines. Please. All right, while Mr. Sharmatov is not connected, let's invite our next guest, and maybe he will connect later. Anton Balakin. How about, yes, Mr. Balakin, please welcome. He's from Peter the Great Polytechnic University. He's going to be in person. Here to give a presentation on the opening features of a gas turbine, working on a mix of hydrogen and natural gas.
Good evening. I wanted to see the peculiarities of work of gas turbine unit when using the mix of natural gas and hydrogen. And it's a promising trend because it brings down the hazardous emissions into the atmosphere. According to the order of Russian Federation government from the 29th of October of the year 21, number 3052, it's planned to bring down by the year 50 the emissions down to 1,830 million tons of CO2 equivalent. There was also the order of the government of Russia from the 12th of October of the year 20, number 2634R. There's a plan developed for the development of hydrogen energy up to the year 24. So they are planning to develop, design and produce the relevant turbines that will involve the usage of hydrogen. So this is the scheme. We are planning to use such a gas turbine unit. In my study, I studied the heat scheme of the researched gas turbine unit. It consists of the input, compressor, combustion chamber, compressor turbine, power unit, etc. The usage of hydrogen is provided on the slide. This is the temperature mentioned before and after the combustion changer, and the content of the fuel mix that included the natural gas and the hydrogen. I used different proportions and calculated the results. On this slide, you see the emissions and the mass ratio of the three atom gases. Three atom gases, that's mainly CO2. So you may roughly regard it as the content of CO2 in the emitted gases. As you see, the more hydrogen, the less CO2 is emitted. If hydrogen is 100%, then there's no CO2 emitted at all. Here you see the specific useful work of the unit at different temperatures, 1100 Kelvin, 1200 Kelvin and 1300 Kelvin. The difference may be explained that first the temperature of the hot gas goes down, and then there's a high consumption of fuel. On this diagram, you see the dependence of the efficiency of the gas turbine unit depending on the three different temperatures. And if the share of hydrogen goes up, the efficacy goes down. This may be explained by the fact that hydrogen has a lower combustion temperature. So if we switch to pure hydrogen, less heat is emitted. Thus, we spend less fuel. When at entrance to the turbine, the gas temperature goes up, then the efficacy may be obtained by improving the pressure. Although this process is not an easy one technically, it's not always efficient to raise the temperature. In conclusion, let me tell you, yes, really hydrogen helps to bring down the hazardous emissions, but certain problems arise, like the efficiency goes down, and this is a problem that requires a serious research of the relevant technologies. That's it. Thank you for your attention.
Thank you for your talk and presentation. Are there any questions in our room? Do we have questions in chat?
There is a question in the chat. What's the optimum content of hydrogen for the gas turbines of the future?
Касательно данный вопрос.
Well, we're planning to use 100% hydrogen. Methane and hydrogen mix is just an interim step. As for the future facilities, they will use only hydrogen, but such units are yet experiments. As for the content of hydrogen, it's difficult to determine it because such units aren't yet widely used, and different patents point at different content of hydrogen. In future, 100% hydrogen, or at least 80% of hydrogen in a mix.
Okay, thank you. Thank you for your answer and for your presentation.
Yeah, thank you so much. We have two colleagues from the Noyabrsk Energonets, Vitaliy Mylitsky and his co-author with their presentation. They're going to give the presentation on modernization of substation technical condition, monitoring systems.
Good evening, dear colleagues. Let's continue the topic of the technical condition of the equipment. So this is a presentation on modernization of substation technical condition monitoring systems, stations of 110 by 35 by 6 kilovolt. Technologies develop, and this pushes us to use more effective and more perfect solutions. And there's a transfer from the classical approach to the risk-oriented approach. So do repair where it's necessary and when it's necessary. We improve the control of such conditions in our company, and we used different methods for diagnosis, non-destructive control, and by trying and testing, we have formed a pool of methods which are optimal the objects at the older units and facilities. And we've analyzed the older the equipment, More frequently, it has shut down, so that's logical, but we used calculations to prove that. These diagrams prove that the older equipment in same geographic places is more frequently getting out of order. Hence, the losses due to the shutdowns are higher. Classical approach is diagnosis of electric equipment by using portable devices like heat vision, vibrodiagnosis devices, and the next stage for development of diagnostics shall be online monitoring. That's permanent, continuous control of a technical condition. Brief description of the proposed solution path for substation. It consists of several solutions. First, we place the diagnostic sensors with the preset parameters, and they include such important parameters as monitoring, control of moisture content, partial discharge sensors, input monitoring, temperature monitoring sensors, gas analyzer, voltage regulation control, vibration monitoring, and cooling system. That such software and hardware enables us to make the decisions. One of the solutions is based on equipping of the substation with the stationary heat vision modules, thermal imaging monitoring. The thermal hose shall be installed on the lighting fixtures on the street lights. They'll be installed in the units that can be controlled directly and visually. So there'll be the heat vision or thermal imaging relay or temperature sensors. Thus, we'll get a complete control of all the bottlenecks, contact connections of the facility. Thus, it won't be necessary for personnel to visit and do the control. The effect of the introduction of online monitoring systems that will save some money and labor and improve reliability of the system. Will save on transport as well due to the no necessity of visits, and thus we'll be able to determine better the terms of the planned repairs. What investments are necessary? The economic justification of the project is made, and the payback period is around 5 years. The project shall enable us to get the necessary tools and to actually assess the realistic condition of the equipment. Thus, will increase the inter-repair period of oil field equipment. The system is compatible with the company's existing systems and projects. And timely decision making based on the technical condition of the equipment. If this project is implemented, it will be one of the main stages of predictive analytics introduction based on machine learning and artificial intellect. All the tools shall be digitalized, and so shall be the parameters. I will be happy to get your feedback. If you're interested, we'll be happy to get in contact with you. You have our contacts on the screen.
Thank you for your presentation. Very interesting. So, do we have questions? Could you please tell me, is it possible not only to do this process online, but also to automate it? Because I have seen there is still 464 people hour required. Is it possible to approach like zero?
I saw on the slide, you said that still 464 man-hours shall be necessary. That's less than before, but can it be zero? Can it be done not only online, but absolutely manless, automated, to be close to zero? Well, in future, it's possible. That's when predictive analysis shall be able to be made, but still repairs are necessary, and repairs are usually made by people. On our slide, we've provided just the first stage of the transition. In the right part, that's the current level of repairs. Some repairs may be delayed if the condition diagnosed is okay. So we've calculated the labor expenses. They may be cut down, and the repairs may be delayed even more, so we'll attract even less personnel, but not zero yet.
Thank you for your answer and your presentation. Thank you.
Okay, we have our next guest.
May I ask a question, please? In Russia, is anything of a kind being used in practice? I have heard about some digital substations, but do they have such a system built in of preventive analysis, or is it yet being developed? Thank you for the question. Such a solution is used successfully in substations in some of the regions, and it's used successfully. The system is called PARAM. Thus, they save on capital repairs. Thank you.
Thank you very much. Our next speaker is Kirill Lutkov, also from Noyabrsk Energoneft, subsidiary of Gazpromneft. Here to give a presentation on strengthening and maintenance of soils. And again, with regards to Sharmatov, we don't see him in the chat. If he is to present himself there, he will be heard. Thank you very much.
Good day, dear colleagues. I'm the Chief Master of the aerial line service of Gazpromneft, and the topic of my project is strengthening and maintenance of soil to strengthen the pile foundation of supports of overhead lines. Well, new deposits are being developed in extreme north, and a lot of overhead lines were built in the conditions of permafrost, like thousands of kilometers of lines were built per year. Difficult meteo conditions and soil conditions created some problems later on for the operation of these overhead lines. And they are in the permafrost area, and sometimes frost is damaging the soil, and also in spring there's melting. It's a cyclic process, so quite often the foundation of the piles are weakened. Thus the aerials are bent and sometimes are falling. We are looking for the economic method of strengthening of soil in the conditions of permafrost. We have the objectives of the projects as follows: to identify the problem, to analyze the modern methods, and to choose the best method from the point of view of economy and technical perfection. There's the injection curing technology, the thermal stabilization technology, and the strengthening of the foundation with cross piles. We studied the issue and came to a conclusion that injection curing is not suitable in permafrost. In swampy areas and in winter you can't do these works. As for the thermal stabilization and cross piles, let's discuss that in detail. Thermal stabilization of soil is as follows. These are tubes charged with a cooling agent, which is a liquid. We drill the hole next to the pile, and that comes the process of cooling. The cooling agent takes away the heat from the soil, and in the upper part there takes place the evaporation. So we cool this soil, and it's a cyclic process. Next technology is reinforcement of foundation with cross piles. They work like anchors. There's a drilled hole next to the pile, and using anchors we connect it to the existing pile. That's to support them. The project was developed, it's a testing project, and we've calculated the cost of introduction of these technologies. Thermostabilization of the soil is 2.5 million. As for the cross piles, the cost is around 9 million. Well, we also made a comparative analysis of the two methods, the capital repair, using both methods. 20 piles to be repaired makes it 56 million. And this enabled us to determine the following. The technology of thermostabilization and cross piles is feasible, and such technologies make us save on the capital repair and to bring down the number of failures. So these methods are quite promising, and they may be used in different conditions. Thus, the bearing capacity of the piles are improved. The project is rather promising. Installation of soil thermal stabilizers paired with cross piles enable us to have better sustainability and a reliable transfer of energy to the consumers. The project proposes the introduction of technologies, and at the end of the pilot test period, we'll develop the recommendations for the further introduction of the technology. Thanks for the attention. Questions are welcome.
Thank you for your talk. So, dear audience, do you have any questions to our speaker? So, may I ask you, when are you going to plan the test period, the pilot period for this project?
You've said that you are planning to do the pilot project. At what time? That would be interesting to learn the results. We don't have the certain time planned, but in the near future, I hope. That's really very interesting, because recently more and more piles are falling off the aerial lines since the climate is changing, and the areas of permafrost and the falling of the aerial lines supports causes big economic losses.
Yes, we're going to welcome our next two guests from Leti. They are Lilia Ziganshina and her colleague, Ksenia Porotnenko. They're going to give us a presentation on improving the dynamic characteristics of an elastic electromechanical system. Please, welcome, colleagues. He's not in chat, so.
Dear conference participants, let me provide our study on the topic improving dynamic characteristics of the elastic electromechanical system. The objective of the project was creating the optimal regulator for sustainability of the electromechanical objects in variable parameters of the system, so that the necessary quality parameters are obtained. So optimal regulator and assessment of efficiency of the synthesized system.
Are you going to show the presentation? Are you going to share the screen with the presentation? Perfect. Thank you.
So if the object can be operated, that makes it possible to create the regulator of the condition. It's described with an equation provided on this slide. The synthesis of the optimal regulator includes the finding of the matrix of the K figures. It should be such so that the synthesis of the system with the exciting impact, but the root square function is minimized. We used the Riccati equation. The procedure of calculation of coefficient of the optimal regulator was done using the software MATLAB, using the standard function LQRY. Y, and in it there were the parameters of the system matrix Q and matrix R, which is equal to 1. However, the synthesis of an observing device is not always possible to measure. Sometimes there are no sensors for metering, sometimes sensors are not precise enough, or sometimes they are not wanted to be installed for some reasons. Well, our elastic moment cannot be measured. To determine it, we are using the observing device. Observation matrix. The object is only completely observed when the matrix is in the order of the system. Our system is completely observable. This is the layout of modeling for the electromechanical system with optimal regulator, and for that, we used the measurements of elastic moment. The linear equations system include the regulator and observer, the contour of the current. We've done the division, the contour of a reverse connection. This is the study of a synthesized system for sensitivity to changes in the parameters of the system, varying the moment of inertia of the second mass and varying the time constant of the elastic moment. And this may cause the speed of the system activity. The transfer process doesn't change in a certain range, and when the value goes up, there is overregulation, and then there's a fluctuation. This is the study of a synthesized system for sensitivity to changes in the parameters of the system, varying the coefficient of internal friction. When the coefficient is exceeded, the time of regulation goes up, but not significantly. Here is the reaction working out external disturbances. The optimal regulator, yes, the statistic error is around 30%, and the dividing link, yes, and the exciting is done within 1 second. Conclusions. The main objective is the modeling and synthesis of elastic electromechanical system. The optimal fourth order regulator with feedbacks of the vector of state variables was determined. That was the result. A full order observer was developed, and sensitivity achieved was low. The sensitivity achieved was low to changes.
I see we've got a question here.
Good day. Thank you very much for the presentation. Very interesting. Please tell us, what value did you use? What was the criteria? Why did you call the regulator Alaska? What did you compare with? With what other regulator? I know about quasi-regulators, linear regulators, some classical regulators. Why did you call your regulator optimal? And here is one more question. For which object is this study aimed? Optimal regulator provides a linear square root function of the quality. Optimal regulator is named so. There are also model regulators, for example, that's the physical name. And we conducted the comparison with the model regulator that works using a slightly different principle. There, the desired parameters are set dynamic characteristics of the system. Next, there's conducted the study of the required polynomial, and then the system is created. Our optimal regulator is set by a setting of the Q matrix. Initially, it's an uncertainty. There's a certain fuzziness in setting of these parameters. So we studied the way the system parameters change depending on the introduced Q matrix. Yes, but what object is this study for? For a DC with elastic connectivity. For robots, yes, it's a robotic complex where the system may be presented. Now these studies are very popular, and a lot of studies are conducted on this topic. So we were interested to make such experiments and to see how the different regulators shall impact the system. Yes, I would like to see the dynamic parameters of your regulator as well. If you will continue this work, please provide the dynamic parameters as well in the future.
Thank you, and thank you for your comments. Thank you for your presentation.
Yes, we have a long-awaited presentation. Yeah, Yuri Sharmatov from the Yablonsk Energoneft. We finally have him with us, so this is going to be very, very interesting. Please welcome.
Can you see my presentation now?
Thank you very much.
Yes, sir. I'm Yuri Sharmatov, and I'll tell you on diagnostics of cable line 635 kV by partial discharges. Our company is using some 670 kilometers of cable lines, including 231 kilometer of polyethylene, which makes 74% of the total length of all the cable lines of the company. In the past 5 years, we had some 40 failures, shutdowns, emergency shutdowns due to the faults of the cable lines. And we also had losses in oil production due to that, some 455 tons. And it's a lot money-wise. In case of every emergency, a team had to be employed to repair the failure. So the methods, high voltage testing and heat vision is not sufficient to bring down the number of failures of the cable lines. I suggested a method that will enable the number of shutdowns caused by the cables. If we compare my method with the already used methods, you'll see that diagnostics of my type has a number of benefits. I will be able to determine not only the emerging defects present, but also to find out the place where they appear, will detect them early enough. Partial discharge is not used, so there'll be no negative impact on the cable lines. When the project is introduced, we'll be able to determine the technical condition of the line at the moment of diagnosis. And take a look, we'll be able to analyze and also forecast the technical condition of the lines to find out the size of probable future failures and thus prevent the emergencies. Our company has already tested the portable device produced by Megger company. One defect was found on the cable line of 35 kilovolt, and conclusion was made to improve the control of that cable lines. Also, 4 defects were removed on the cable line of the 10 kilovolts. So they were detected and removed of those failures. So the method is viable, and if we use it, we'll avoid certain emergencies. There are 2 basic methods for cable line diagnosis with partial discharges. There are the stationary systems and portable devices. Comparing these 2 methods, the operating company decided that portable devices are better, since the diagnosis then shall be much cheaper. The main part of the project is as follows. First, we need to buy those portable devices for diagnosis of cable lines. If we buy 3 devices, it will enable us to use that for some 70% of the cable lines of the company. Then we need to develop and approve the standard for starting the repair or for improving the control or the monitoring of the cable line. And we also should decide on the frequency of the diagnosis. We also need to train the employees to use these diagnostic methods. We've done the calculation of the economic feasibility, and it proved that the payback period of this project shall make 3.9 years, a bit less than 4 years. Main conclusions. If we use this diagnosis method using partial charges, we can determine the current technical condition of the cable line. We can prevent the emergencies, forecast them as well. We can exclude the idle time of the equipment and eliminate the equipment downtime. It may be used as an alternative to the continuous impact when testing the AC voltage. Thanks a lot for the attention. That's it with my presentation. I'll be happy to take your questions.
Thank you. Thank you for your talk. Dear audience, are there any questions? May I ask you a question? Your colleagues told us about an online process of checking. Is it possible to do this type of check online as well? This type of diagnostics?
Your colleagues have described a similar system, and they proved that the system may be made so that it checks everything online. What about your diagnosis system? You may have portable devices, but what about the devices that will do everything online? Online monitoring shall be the next stage of our project. At present, at the current level of technology development, the system of online monitoring works rather as an indicator. The presence of partial discharges at the operation load, and such portable devices detect the partial discharges at the load which is lower, voltage that is lower than the operating voltage. That's a more high quality diagnosis, but it still requires certain expenses, labor and time, that's for sure.
Ladies and gentlemen, we have our last presentation for today. This is going to be Daniil Mikhailov from Leti. He's going to give us a presentation on functional capabilities and development direction of the Educational and Scientific Laboratory of Automated Systems of Sea Transport, ATU Leti. Mr. Mikhailov, we welcome you. We do welcome you to give this ultimate presentation.
My greetings, dear conference participants. This is my presentation on the functional possibilities and development of the labs at LETI. The training stand of the system consists of two sets, the electric station and the energy unit, and this enables us to study each of these complexes separately. If we have the uniform system, we can switch the feeder from the shore network to the vessel electric station. The vessel electric station includes the main distribution board, the operation panel, and the engines. The engine, the ship power plant, and the DC engine. The set enables us to research the systems of excitation of the generator, active and reactive loads, protection of generator against overload and underload, and the modern functional devices for automation of the vessel electric stations. That's the propulsion system operation. This set enables us to get to learn certain characteristics of the propeller with different angles. They also depend on the vessel settlement. We've developed the system of automatic synchronization of generator units using microcontrollers, and certain tools were introduced for synchronization. The diagrams of currents are presented on this slide. You can see the load distribution study result, active and reactive loads. You see them on this slide. Thanks to the presence of imitation of the propeller unit, we've studied the impact on the electric grid, on the quality of the electric energy, as well as the underload and overload. Lab development in the field of renewables sources of energy. We are planning to study the hybrid electric station with the probability of synchronization of both the AC and DC. Asynchronous engine, shaft to shaft, has a synchronous generator on permanent magnets that enables to imitate, with the help of the synchronous engine, different sources of mechanical energy, such as wind generator, gas turbine units, combustion engines, and hydro turbines. The main task of the hybrid electric station is to study the possibility of the work station with the grid, with the changing RPM of the engine. Year after year, the improvement of energy efficiency is becoming more and more topical, and we should switch to the renewable sources of energy. So our lab enables us to conduct quite a wide range of studies in this field. Thanks for the attention. I'll be happy to take your questions.
Okay, thank you for your presentation and talk. Do we have a question? No? Okay, I would like to ask you, do you work with the students or like graduate students maybe? Do you access the students to this laboratory for an internship, maybe, or research project?
I undergraduate and I now under master's degree
Next year, I'm planning to become a postgraduate student of LETI. I'm using this unit for my research. I'm writing scientific articles, so this electric station is a big part of my work and future. work. I'm planning to connect my future and my life with Leti, and I'll be the active user of that lab. Thank you.
Okay, with this talk, we are going to conclude our event today, and it's an interesting moment that today, in the day when Nobel Prize in Physics is awarded, one of the laureates, Hasselmann, got this prize for modeling that reliably predicted global warming. And the topics we discussed today about sustainable energy and clean transportation and like alternative energy sources should also help in this regard and in this matter. So we are thanking everybody for participating and hope to see you on our next events.